This section is going to really focus in on the file system, and this graphic really hits home for me because I am just that old. Starting on the right and moving to the left. So this hard drive is the older version. This is old technology. This was high performance when I was growing up. Then we moved to what's called a solid state, and now we've got these M.2s, and there is other newer, fancier technology. But point being, technology is changing. These older hard drives, HDDs, these would have physical spinning parts. They're called platters. If you've ever taken one of these apart, it's a bunch of metal discs that spin really, really fast, and you have high performance magnets in these things. You know, fast moving metal parts and magnets inside of a computer. What could possibly go wrong? Yes, these are very error prone, they're very noisy, and they generate a lot of heat. Heat is always a problem inside of a machine. We move to SSD, or solid state. These are, as the name implies, solid. There's no moving parts. These are just bricks. And if you took one apart, you would just see rows and rows of little chips. That's all it would look like. They're much quieter, much faster, no moving parts, less error prone, but they are more expensive. And now we have kind of a condensed version of that called an M.2 NVMe. These things are lightning fast. Just hit warp drive in Star Trek. That's how fast these things are. It's blistering fast. And they can have the same sizes as these older drives. Now, these older drives are much cheaper. The newer drives are more expensive. But what are we really talking about? The file system. We're interacting with hardware. Now, this little diagram, we're going to zoom in, is kind of an exploded view of a file system, what we're going to be talking about here. So let's go ahead and just zoom right in. We have disks. And these, we can have more than one, but these are the physical hardware. Then you have partitions. And I often hear people use partitions and volumes interchangeably, but they are two distinctly different things. But for the sake of this conversation, let's go ahead and use them interchangeably because it's easier to understand. A partition is an area of that disk. It's basically us telling the disk, this is what we're going to use. Inside of that partition, you would have a file system. I'm sure you've heard of things like NTFS or FAT32, things like that. There's hundreds of different file systems out there. You can actually make your own if you really wanted to. Point being, this defines how we're going to save the files. Notice what's happening though. We have a physical layer, we have an operating system layer, then we have a management layer. Now we have a directory structure. So I have a directory and a directory and a directory. This is the actual information we're storing in green. And it goes down to a file. Then you notice we have format. So a file can have a file format. So for example, a text file is different than, say, a video versus, say, a Microsoft Word document, something like that. So files have their own formats. That format is not dependent on the file extension. You notice I don't have an extension in here anywhere. The extension is just a helper for the operating system to tell the operating system what format that file is actually in. Whew, that is just confusing. But you get the point. There's a lot of moving parts. Now, what we're going to be working with here is directory structures, files, and some minor file formatting. One question I'm often asked is, can you really elaborate a bit more on the difference between like a disk, a partition, a volume, and free space and all that? Okay, so think of this gray area as a disk. Inside that disk, we're going to tell the disk we want to use a region of that. That's called the partition. It's a logical portion of the disk. And then a volume is a logical portion of the partition that actually contains the file system. Just to clarify, but I do hear people use partition and volume interchangeably, but they're two distinctly different things. So you have the physical drive, you have a region of that drive, that's called the partition, and then you have a region of the partition that's called the volume. And yes, you're going to see people in the Q&A section just argue with me about this. That's fine. Go to Google, look it up. You may even find different information on Google because that's just how confusing all of this is. And then any part of the disk we're not using, i.e. in a partition, is called free space. Ooh, that is crazy. All right, let's go ahead and let's look at our little virtual machine here. And I am on Linux Mint, but almost every operating system has something in it that will show you the actual disk here. So you can see on this little 27 gig virtual hard drive, I have a file system. This is a FAT system. It's 537 megs. And then I have a partition with a file system of ext4. And then I have 1.1 megs of free space. Why is this even here? Why am I not using this? Because of the way the computer works, it expects it to be in certain blocks, and this just happens to be the amount of space left over that couldn't be allocated into a full block. Notice also it's got a device name here, or I should say a device path, /dev/SDA. This is specific to Linux, I should say Linux Unix variants, and of course, as I kind of thumb through here, you'll see different things. SDA1, SDA5, you know what's going on here. It's SDA and then a number. Now you see what I mean by you're drilling down. Notice it says volumes, not partitions. Okay, so this is the partition. These are the volumes inside of it. This is the actual physical disk. And to kind of expand upon that, I'm going to open up the desktop. We were looking at a virtual machine, but I'm going to show you the actual desktop that I'm on that's running the virtual machine, which is also different. Here we've got our 500 gig Samsung drive. This has got an NTFS partition. This is my Windows partition. I'm actually dual booting on this box, dual booting Windows and Linux. And then inside of Linux, I'm running another copy of Linux to record these videos. That wasn't confusing enough. So you can see the distinct differences here. So this is my Windows box. It's got using a partition taking up the entire disk other than 3.2 megs of space. And then we've got a couple volumes in there. Then we have my Linux box. This has got just one gigantic, maybe I should change that, ext4 partition taking up the whole disk other than 1.1 megs of space. You'll notice that this is highly more efficient than this. I said it. I did it. Go ahead and fight me. ext4 is highly efficient compared to NTFS and Windows in the way that it sets it up. You notice the 3.2 megs of free space on Windows versus the 1.1 on Linux. But yes, it's highly dependent on how you set it up. Point being, we are going to be diving into the operating system, but I wanted you to understand what's going on here. You see right here, size. We don't have an infinite storage device. This is going to have a limit to what we can store. On top of that, you can see disk is okay, meaning yes, all hardware eventually dies. Everything, every man-made component will eventually die. This disk, knock on wood, is okay, but eventually it won't be and I'll have to replace it. So bad things do happen when you're in file system land because you're working under the hood with hardware. Okay, quick recap before we go any further. What we're talking about here is a hard division between the hardware and the operating system. So the hardware typically has a drive and then partition volumes. And then the operating system will work with the file system, which is folders and files. And you notice this is going down. You're getting more granular here. Now, folders are a logical container for files. I want to really understand that, really drive that point home. A folder is not a file itself, although it can have information in it. For example, when it was created, when it was modified, etc., and some permissions. They have other things you can do as well. For example, you can be compressed, even encrypted. That is dependent on the file system. That may or may not be natively supported on your system. Folders contain other folders forming a folder tree. That's right. What we're talking about is, well, something like, and if we switch over to our little virtual machine here, we can open this up. You see, here's our file system. This is our root, /. And then in here, you can go into home, and then whatever user, and then you can go into, let's just say code, cute. And you see what's going on. We're building this file path here, so on and so on, until we actually get to a file. Let's talk about the difference between a folder and a file. So This is where it gets really confusing and people start asking a lot of questions, especially if they're new. So a folder is a region of data located on the physical disk accessible through the file system. Files are located inside of folders. All files are in a folder. Now that folder may be the root of the operating system, but point is the file is not outside of the file system. All file systems start with what's called a root. Even if you cannot see it, access it, or even know it exists, it's there. That being said, from that root, you can have other folders, and of course, those can have files and even other folders which contain files. And the file, of course, can live on the root. Point being, the file, though, is a part of, you guessed it, the volume that's storing data. So when in doubt, a file is in a folder, data is in a file. Now, here comes the confusing part. Folders can contain other folders and files, but folders are also data out on the disk. So is a folder technically a file? No, it's not. It's treated completely different by the operating system. So a folder is a folder, also called a directory. Now, a file is a region of the disk that contains data. Here's the kicker, though. Files can contain other files when you talk about specific formatting. For example, a compressed zip file or a database. It may give you the appearance that it contains other files, but really what you're talking about there is the file format. The actual hard disk or the operating system doesn't care what the format is. It's just a specific region of data. So someone will always come to me and say, well, isn't a file like a zip file technically a folder? No, it's still just one single file, one region of the volume where the data is stored. So let's take a look at an actual file. And this is a very high level view. You're going to have two types of files. You're going to have a text file. For example, it's going to contain hello world, or a binary file, which is going to contain binary data. Now, when we say binary, this is not something a human would read normally. For example, a text file is human readable, where a binary file is encoded in some manner. Now, I say some manner because there's all different types of encodings out there. And yes, even text files can have different types of encoding as well. So on the surface, it's not as simple as this graphic would really have you believe. So for example, a human readable text file may be encoded in ASCII, it may be UTF-8, 16, or 32, where a binary file is something you as a human being would never be able to read directly. Instead, you would see like a representation, for example, a hex encoded representation of that data. Note that the file extension does not really determine what the contents of the file actually is. Let's take a quick moment to clarify a few things here. We're talking specifically about files, extensions, and formats. At the top row, we have the file extensions. We have, for example, a .txt or a text file. Now, normally you would expect a text file to be human readable, something like hello world. This is human readable. This right here is called a MIME type. This is the type of data you can expect in the file. This simply tells the operating system, open the program that's associated with this file type, and it will expect this type of data. For example, a MP3, I'm just assuming you know what an MP3 is. It's a file that includes sound data, typically songs, is going to be non-human readable, and it's going to have special encoding. Now, you can, if you wanted to, make a .txt file and put non-readable encoded information in it. There's absolutely nothing stopping you from doing that. It's just an understanding or an expectation the operating system has is that the file extension will have the type of data it's expecting. Now, understand what we're doing here. We are telling the OS what to expect. So if you make a .txt file and put hello world in it and the user double clicks that file, it should open in like a notepad application. MP3s would open in your MP3 player, but if you make a text file with a bunch of encoded information in there, it will still open in the notepad, but you'll see the encoded non-human readable representation of the data, meaning you won't actually see the data itself. You'll see what the notepad-like application is going to try to display. Let's start at the simplest of levels. We're going to look at just simply an I/O device. Why? Because the QIO device is the base class of all devices. Notice I said I/O device. The letter Q denoted in Qt, but everything out there works with an I/O device of some kind. Now, if we look at QIO device, this is the base interface. Notice that keyword interface of all I/O devices in Qt. Meaning, because it's an interface, we're not going to work with it directly. We're going to work with something that inherits it. For example, QBuffer. But you notice there's sockets, files, processes, all sorts of things use a device. Now, QBuffer, this little guy, provides a QIO device interface for a QByte array. So this is something we've become very familiar with. Now, if we look at the API for this, what this does is it allows us to say, hey, we want to be able to open it, close it, and then do things with it, like read data, write data, things like that. So we want to treat the QByte array as if it were a device. So let's go ahead and start with that. We're going to say QBuffer. Let's just call this buffer. The first step is we need to open it. Think of it a lot like opening the door to a room. So I'm going to say if buffer.open, and notice it's going to return a bool. Now I want to say QIO device, and let's look at the open mode flags. There are a bunch of them, but they're very self-explanatory. Append will put information at the end, existing only, new only, not open, read only. You're not going to use all of these. Most of the time, what you're going to use is read only, write only, append, and read write. And as the names apply, it really limits what you can do. So for example, read only means you can read the file, but you cannot write to it. Write only means you can write to the file, but you cannot read from it. Read write means you can do both. There are special use cases why you would do that, but basically you want least privilege, meaning if you're not going to write to the file, open it in read only. That way other things can read it as well. For example, if you open it in write only, you're locking that file, and based off your operating system, other processes may not be able to write to that file because it is now locked. That is something that is very bad that could happen. So if you ever tried to write to a file and it says file in use, that's exactly what's going on. Some other program is writing to it and never closed it. So we can shorthand this and we can say read write. We are going to read and write. Now this is going to really lock that file down so nothing else can really use it. We want to just assume, because we're working with some sort of device, that worst case scenario happened, and of course, this failed. So I'm going to say QInfo. Could not open the device. We just want to say right off the bat, nope, sorry, couldn't do it. Now, if we were able to get in, we want to let the user know the device is open. So we've now opened the door and we're staring into the room and we can do things with it. Now, before I do anything else, I'm going to close the door. Whenever you open, you should close. Why? Because you're telling the operating system, I'm done working with this, and now other things can work with it if they need to. Then, once you have this kind of template down, you can actually start working with it. First thing I'm going to do is I'm going to say buffer dot write. We have some options here. We can actually put a const char pointer to data, or we can work with a QByte array. So let's go ahead and back up here. Let's make a byte array. And let's just simply call this data. Give us an initial value of hello world. Horrible spelling included at no extra charge. And let's go ahead and write a bunch of data. I say a bunch, but it's really not that much. We're going to write that out 5 times. So I'm going to say for int I equals 0, I is less than 5. Took me a moment to figure out why I made that mistake. Anyway, so what we're going to do now is we're going to say our buffer, our I/O device, we want to go ahead and write. And we're going to write that data out there. Now, I'm also going to write out some special characters. I'm going to say buffer.write. And I'm going to give it an escape sequence of carriage return line feed. If you don't know what a carriage return line feed is, it's the same as hitting enter on the keyboard. It just makes a new line. But that's treated slightly different in every operating system. Most operating systems just look for new line, but Windows, of course, does the Windows way, which is /r/n. So kind of the universal format is everybody dumbs it down for Windows, and they do /r/n. So we're writing to that buffer. Now, when we get into files, you're going to be told to do something called flush, which would look like this. But you notice how IntelliSense isn't popping up, and if you go into the help system, or if you just do it here, it's going to say, no name, because a buffer has nothing to flush down to. It's in memory, so it's automatically there. But whenever you see the term flush in an I/O device, basically what you're doing is you're ensuring whatever you wrote gets flushed down to the actual device. All right, now that we're in here, what we've done is we've written to that buffer, and think of it like reading a book. We're now on page 5, and we need to go all the way back to the beginning. So I'm going to say buffer, and we want to seek. And notice we have an offset. We're going to go to 0, which is the starting position. That is the very beginning of that device. And I want to just simply read this. So I'm going to say qinfo buffer, and we're going to read the whole thing. Notice how you can read a certain amount, you can read a line. We're going to just simply read all. Now I want to let the user know, hey, we are going to close this buffer. And at the very end of all this, let's go ahead and tell them we are now done. Now, in case you're going, no, wait, I really want to know how to read line. Don't worry, we're going to cover all that. I'm going to show you how to do it in future videos here, but I'm just showing you the basics in this one. Go ahead, save run. Assuming I didn't mistype anything, this is what you're going to see. The device is open, and we write hello world, carriage return line feed 5 times, and then closing the buffer. We've read that back. We are now finished. That's it. It's really that simple. So some major takeaways, quick review. I know we covered a lot here. When you're working with an I/O device, you're going to work with a class that is using that device. I should say that interface. In this case, we're working with qbuffer. You're going to open the device using a open mode, do something with it, and then make sure you close it. Now, when I say do something with it, typically you're going to write, you're going to read, or you're going to seek around. Let's just dive right in. We're going to learn how to write a file. Why? Because, well, it's very fundamental. Working with files is very, very basic. We're going to look at qfile, and as the name would imply, it's the Qt's way of working with files. Qfile provides an interface for reading and writing files. Now you see the word interface and you get a little thrown off and go, uh-oh, I got to use an inherit. No, you can work with qfile directly. Now, this thing is actually pretty awesome, but notice it inherits qfile device, which of course inherits QIO device. So really not working with anything we haven't already looked at. We're just adding a little bit of complexity at a time. And of course, we are going to touch on, you guessed it, QDateTime. We covered this in the beginner's course, but just in case you skipped that course, QDateTime does exactly what it says it does. It works with dates and times. It's very simple, very easy to work with. And its API is just, well, ridiculously simple, as you're about to see. It's actually a very complex class under the hood if you ever look at it. So let's go ahead and first thing we're going to do when we're working with a file is specify a file name. I'm going to say test.txt. Notice what we're doing. We are creating a file name, which consists of a name, a dot, and an extension. And the extension, of course, tells the operating system what program would be most likely to open that. We can write any extension we want. For example, MP3, zip, and so on. But of course, if we deviate from the type of data and the encoding that we're working with based off the extension or the type, whatever you have in your operating system will not understand how to open that. So for example, if I put MP3 and you put text, human readable information in here, your MP3 player is going to open up and it won't know what to do. And it's going to say like corrupt file or something like that. So to begin with, we're going to say .txt. That way it'll just open up in a notepad style directory. The other thing to note is we're not including a directory. This is just a name. We don't have like, you know, C drive something or /root /folder /something. We're not doing any of that. We're just saying file name extension. And what this is going to do is put it in the current application directory. Very simple, very easy concept to understand here. So I'm going to say qfile, and let's go ahead and make a file, and we want to give it our file name. And we can got 5 different options to choose from, but we're going to use the qstring. So I'm going to say file name. Now what I want to do is say if, and I want to say file, open, because remember we're working with a device. That's right, we got to use an open flag. So I'm going to say QIO device, write only. Meaning we're going to be able to write to this file, but not read from it. Why? Because I don't care to read from it. I just want to put information into it. So we're doing least privilege here. Now I want to, as we opened it, see if that failed. I'm going to say qinfo. And we're going to get the error string. And it does exactly what it sounds like. It's going to return any error in a string representation. So if we're unable to, because we lack permissions, it'll say access denied, and there's a whole host of things that could possibly go wrong. And of course, they're all operating system and even file system independent, but it returns a human readable description of what went boom. Now, the other thing I like to do, because we have opened it, I'm going to immediately say, okay, shut that door. That way we don't have this file open forever and ever. But note, when qfile goes out of scope, it should automatically close that for us, but I'm not going to rely on it. All right, let's go ahead and say qstring, call this now, equals q date time, and I want to get the current date time. And if you're coming from Qt5, they have overly simplified this class. I absolutely love the new API. It's much, much simpler to work with. I'm just going to say toString. And of course, you could do all sorts of fancy dates and times and things like that. Again, if you're ever questioning what's going on, simply highlight F1, takes you right to the spot in the help file and shows you exactly what you need to do. So we're just going to get the current date time and get the string representation of that, shove it into a QString. Now I'm going to make a qbyte array. Call this data. And we're just going to fill this up. Say data.append. And we're going to add in the now variable, which is a QString, to a local 8-bit. Don't necessarily need to do that. I'm just showing you you can do it. Returns the local 8-bit representation of a qbyte array. Now, this is encoding. You notice there's like 2 Latin 1, 2 UTF-8. We just want local 8-bit. You can do this in any format you want. I'm just showing as an example we can do that. Now you may be asking, well, why? Well, it just really didn't matter, to be brutally honest. I just wanted to show you you can add in certain encodings. All right, now encodings will get more important as we get more complex, but right now we don't really care so much about encoding. So for example, a QString is automatically UTF-8 and it's Unicode, and we just said do that in local 8-bit. Now that we've got our qbyte array, which is our data, we want to write that down to the disk. So I'm going to say file.write. And let's go ahead and put the data, that byte array, in there. It's really that simple. Now we're going to close. Now if I hit F1 on close, you'll notice it calls flush automatically. Remember, flush flushes any buffered data. This is why we covered buffered first. Buffer data to the file. So anything that's sitting in memory land is going to get written down to the disk as soon as we try to close. So often, and I'm guilty of this too, you'll see people say file.flush followed by close. And you really don't need to do it. There's no harm in doing it, but you really just don't need to. And then from here, I'm going to say qinfo wrote to the file. Just so we know, hey, we actually did something. This is a very simple app, but let's review super quick. So we're making a file name. We're getting a file with that file name. We're attempting to open it in write only, meaning we are now going to lock that file and we can put data to it, but we cannot read from it. Now, you may be curious why I didn't do read write, because I wouldn't have that penalty. Some operating systems have a penalty for read write. I want to avoid that, and I want to just simply stick with what I'm doing, which is to write information to a file. So I'm going to say write only. From there, I'm just getting the string representation of the date time. I'm going to put it into a byte array in a local 8-bit, and then I'm going to pump that out to our file. Notice I did not set an encoding here. What's going to happen under the hood is this is going to do one of two things. It's going to be a constant char, or Qt in the background will convert that, cast it to a Q string, which is going to be UTF-8. All right, let's go ahead and save and run. Ta-da, wrote to file. Now, where is that file? Notice I did not include a directory. It's going to be in our current directory. So let's go find it here. Here's our build directory, and here is our test.txt. And just to prove, I'm going to move to trash, go here, let's run this again. Ta-da, wrote to file. Go back to our directory, and there it is. Double click it, and notice it opens in our little application here. In case you're wondering what this one is, this is simply Zed. It's a small, lightweight text editor. It comes part of Linux Mint. You may have notes or text document or notepad, depending on your operating system or your distro, whatever you're using. Point being, anything that opens a .txt by default will open your file, and we see there is the QString representation of the current date time along with hello world. This is ridiculously simple to work with. Now, what would have happened if we had changed this? And let's just play around with this. Let's say PNG. I want to put it as an image format. Or actually JPG. That's more widely known format. Save and run. Notice it works. We wrote to the file, and if we go out, there's our test.jpg. But if you click this, notice how could not load image. Why? Because it's expecting it to start with hex 54, hex 68. We didn't do that. We put human readable text. So if I right click this and go to other application, I got to really hunt for this thing. Let's find Zed here. There we go. Our test.jpg contains our plain text. That's what I mean by it really doesn't matter what extension. We don't really care. The extension denotes what the operating system is going to try to open that with, but we can work with any extension we want. Now, let's slow down just a little bit here, and I want to look at appending files. It puts the data at the end of the file, and we're going to take virtually the same code, and I'm going to just copy and paste it in here. This is the same thing from the last video, just in case you skipped it. Let's go ahead and take a look here. We have a file name, test.txt is going to write it to a current directory, Q file, and then we are going to file open, but notice I have append. This adds to the end of the file. And then, of course, we're adding our date time, blah, blah, blah. It doesn't really matter what we do from there. As long as we're pumping data into that file, we close it. And then we have append to file. I didn't want to take the time to write all that out because it's virtually identical. The only thing that's different is this line right here, append. So if we look at the modes, we have write only, read only, read write, which we've already touched on, but append often really raises some questions. And if you highlight it and hit F1, no documentation available. So people often go, I don't understand what's going on here. So this does a few things. It opens the file in write mode, but then goes to the end of the file, and then whatever you add gets added or appended to it. So you're not overwriting the contents. I don't know if you caught it in the last video, but as I ran this program multiple times, we only had one line in there. You're going to see something totally different in this video. So for example, the previous video had just one line. This video, because we're in append mode, it's going to open the file and then go all the way to the end right here and then start adding information to it. Every time we run it, more information will be added. All right, let's go ahead and back out. You notice I do not have a build folder for this guy right here, but just in sake of interest, we're just gonna move to trash on that. So there's no secrets here. Let's go ahead and run this. Ta-da, append to file. When we go out, now we've got a folder. There's our test.txt, and I'm gonna leave this open. And one thing I love about Zed, the little text editor I've got here on Linux, is that it will tell me if something's changed. So I'm going to close this, run it again, append to file. When I flip over to Zed, you're going to see, hey, it changed. Do you want to reload it? And I'm just going to go, yeah, why not? Notice there's 2 lines now. As I run this, it will continually go to the end, and then whatever I add will get appended to it. So if you're ever confused between write only and append, they're virtually identical. Now, I have to caveat that some operating systems are slightly different in the way they handle append. And again, QIO device append will have nothing in there. You'll have to go to the open modes inside a QIO device and hunt that down and figure it out. This should handle it in a cross-platform manner, and major disclosure, I have never once had a problem with append, but just understand the fundamental difference. Every time I save, run, we are now adding data to that file, and it's getting continuously bigger. So if I go back here and reload, you see, voila, we've got more information. All right, so let's do something different. So far, we've been writing and appending a lot of files, and to be brutally honest, usually my programs end up reading files just as much, if not more, as they do writing files. So reading is exactly what it sounds like. You're going to read information from the file. Let's go ahead and look at how that happens. I'm going to say qstring. Hope if I actually did it right. String, there we go. File name equals. I'm going to say test.txt. Again, the extension doesn't really matter. Let's go ahead and say qfile, file, and we want the file name. Now we're going to say if file open, and I'm overly simplifying this. We're going to make a better example later on, but QIO device read only. Now, you may be inclined to ask why we're doing read-only and not read-write. What if we just decided we wanted to write to the file? Well, read-only on most operating systems does something magical. You and any other program can open it and read it at the same time. That's right. Think of it in terms of like a web server. Somebody visits a web page. How many thousands of people are also visiting that web page? It's because the server is reading that file in read-only mode. All right, so qinfo, we're going to say file.errorString. Very, very similar, hauntingly similar API. And I'm going to drastically oversimplify this. Small files only is what we're going to do. I'm going to say qinfo. Read all. Now you notice there's a read line. We're going to cover those in other videos, but right now we're just going to do read all. And what this does is it starts at the beginning and reads literally the entire file and then gives it back to us. As you might have guessed, this can get particularly problematic if you use a large file, like if you tried opening, say, a 4 gig DVD or something like that. I mean, it's going to be massive and it may have more data than you have memory. At which point many things happen, but it's really dependent on your operating system. Most of them are going to fill as much memory as they can, swap down to the disk, and your program may actually crash. So you gotta be a little careful with read all. That's why I put small files only. Notice what we haven't done. We have not created a file. So if we actually go out to the hard drive here, there's no build folder here. Let's change that. So I'm going to build this thing. Once we get a good build, let's go back out to our directory. Haha. So what are we trying to open? We're trying to open test.txt. There is no test.txt. So what's going to happen when we run this? No such file or directory. Uh-oh. Now, one major thing to really denote right off the bat is we could have done something like file.exists, and it would return a bool telling us if it actually exists. So let's go ahead and do that. Say Control X, and then let's go with qfile, qinfo. And I just want to know if it exists, and then we can show what's happening here. And because that's returning a bool, we could have done, a return function and just not messed around with it. So exists false, no such file or directory. Notice how we didn't have to check to see if it exists before we tried to open it, but of course we got an error string. Now let's go ahead and go in here and let's make a new document. And I'm going to do this manually just so you can see. I'm going to say test.txt. And I'm going to say, hello, everyone. This is a text file. Save that, close it. And let's go ahead and run it again, see what this looks like. Now, you notice, hello, everyone, /n. This is a text file, /n. Now, if you're on Windows, you're going to see something like rn. Again, this is just operating system dependent. But that's a very simple, easy example of how to read a file. This video, we're going to hopefully answer a few questions. I often get asked, we've covered read all, but how do I read larger files? Because read all, let's just face it, is not a great idea, and frankly, it sucks, but it's at the heart of every single tutorial. I've used it myself. So what are we doing? Reading large files. Why? Because read all sucks. We want to break that file into smaller parts, make it easier to manage. We're going to use read line and read. Two functions here. I've got read lines and read chunks. These are going to do two very similar but different things. Read lines, for example, let's go ahead and flesh this out. I'm going to say if, let's say not file dot is readable. Let's go ahead and return. Notice what we're doing there. We're checking to see if the file is open and we have the proper mode, meaning can we actually read the file. Then I'm going to say file dot seek. And we're going to go to the very beginning because we don't trust this Q file. Notice what's happening here. We're getting a Q file and we don't know where we are, so we're just going to immediately go right to the beginning. Then I'm going to say while, and here we want to say file is not at the end, meaning we're going to keep going until we hit the end of this file. You may be going, wait, whoa, isn't this super dangerous? Because we're going to possibly loop forever. No, as we read this file, it's going to move that position forward in the file until it gets to the end, thus exiting the loop. What I'm showing you is pretty industry standard. I mean, it's not rocket science here. I'm going to say file read line. Now, you can have a maximum line length if you really wanted to, but we're just going to read the entire line. Now, under the hood, what does this really do? Well, it's going to look for the escape sequence /n, or new line. So when you hit enter on the keyboard, depending on your operating system, it's doing /r/n or /n. Either way, /n, the new line character, should be there. When in doubt, highlight, hit F1, and it'll tell you the first /n character is red. Now, Windows, you may notice a slight extra character, that's the /r, but most of the time it'll strip it out for you. Now, let's go ahead and look at read chunks, which is similar but different. We can actually take this thing, copy, paste. Notice I'm a huge fan of copy and paste. And everything is exactly the same, except for instead of read line, we are going to .read. And notice what happens here. We have to make a choice. We need to determine the maximum length. So I'm going to read this in chunks of 25. In that case, we're not relying on some special marker in here. We're saying read a certain number of bytes. So if you have a specific structure, we would actually read that structure back. I want to stop real quick and say, we're talking about plain text. If we're talking about binary, there's a better, different way called QDataStream, which we'll cover in a future video. But if you just want to read a certain number of characters, this is how you would do it. All right, that being said, let's go ahead and flesh this out. I'm going to move down here, and I'm going to do some copy and paste just to save a smidge of time because we are not really doing anything new here. We're going to say file name test.txt. We're going to create this manually. File.open. We're going to read this in read-only mode, and we're going to read the lines, put some sort of line marker indicator there, and then go ahead and read the chunks. Remember, it's going to seek to the 0 position. Notice it's looking for test.txt. So let's go ahead and give this a build. And then let's jump out to our hard drive. We're in 810, so I'm sorry, 811. So let's jump into this folder. There is no test.txt, so let's go ahead and create it. That's embarrassing when you misspell test.txt. So this is where we could do something like this. Hello, 1, 2, 3, 4. This is my text file. Notice what we're doing here. We're just hitting enter, and then we've got a line. We could do other things. We could add whatever data we wanted. We could even, if we wanted to, just grab, copy, and paste something. It doesn't really matter what we put in here. We just want some human readable data. Now let's go ahead and run this. Notice what's going on here. So read lines is reading, you guessed it, every single line. We get the /n at the end here. We could trim that out if we wanted to using QString's trim function. That being said, it also grabs all this. Chunks, however, does something different. It reads 25 characters at a time, even if it's grabbing multiple lines. So those are two simple ways of doing it. Which way is the appropriate way? That's a good question. If you're going to use a plain text file, usually 9 times out of 10, you're going to want to read it line by line. But if you need to read a certain number of bytes, it's right there with read. Let's take a moment and let's look at streams. Now, this is a little bit challenging to wrap your head around at first if you're not used to what a stream actually is. But think of a stream, well, like a stream. You're out in the woods and you come across a stream, and it's just really has no beginning and has no end, but there's water flowing through it. And you can see the water in your visible area. That's really what a stream is. You're just going to get a continuous flow of data until something happens and you don't. So as the name implies, QTextStream is Qt's text version of a stream, meaning a human readable stream. And of course, it is a class provides a convenient interface for reading and writing text. This is actually very, very simple. I actually enjoy this class. I mean, once in a while, I get like a little eye roll moment with it, but most of the time it just works. So I've got some code already queued up. I've got a write function, a read function, and of course we're saying, is the file writable? Is the file readable? Blah, blah, blah. And then down here, we're just going to work with a file, test.txt. We're going to open it in read-write mode. So we're going to be able to both read and write. Of course, after we've opened it, we're going to go ahead and close it. And we've got our did something bad happen here. Now, before we really, really dive in, I want to do something here. I'm going to say QText, not QRex, QTextStream. Let's go ahead and say stream. And we're going to go ahead and hand it our file. What I want to do really quickly is just simply say QInfo encoding. And I want to read what the stream's encoding is. Now, in case you're confused about encoding, think of it this way. A file can have data. That data is dependent on the encoding. Is it plain text? Is it hex? Is it some other thing? Now, encoding can get really, really crazy, but we're going to keep it super simple. Say stream.encoding. Returns the encoding that is currently assigned to the stream. Yes, it is really that simple. And if we set encoding, this is where you would define you want UTF-8, UTF-16, this or that, etc., and so on. So if you need a special encoding for a stream, we're going to touch on that very briefly here. So anyways, first thing we're going to do is just simply open that file and get the encoding and see what the encoding actually is. So the file doesn't actually exist. First thing we're going to want to do now is write that file. So I'm going to go here and say qxstream. Notice what's happening here. We can make a new stream and simply attach it to the file. So the stream takes the I/O device and just treats it as if a stream of data is going through. Think of it like a layer on top of the I/O device. Makes it a little easier to work with. We're going to say stream.setEncoding. This is where we're going to actually say, I want to use this specific encoding. And in this case, I'm just going to simply say qstring converter last encoding. There are many, many other ways of doing this. But basically, the qstring converter class provides a base class for encoding and decoding text. And there are supported encodings, UTF-8, 16, blah, 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 so on, so on, and so on. That being said, I'm just going to use the last encoding, which should be UTF-8. That being said, if you click on that, there is no such thing in the help documentation. It's a minor annoyance of mine, but it's there for a reason. So when in doubt, you try to highlight an F1 and it comes up with nothing. Highlight its actual class and then hunt for it. All right, now that we've got that mess out of the way, we're going to say stream. Remember, we've got a stream in front of us. We don't really have a beginning or an end, so we want to go ahead and seek. And we're going to go to a specific position. I'm going to say file.size. Meaning I'm going to go to the very end of this file. This is virtually the same thing as doing an append. We're just going to go to the end of the file and then start writing information to it. So I'm going to say I equals 0, I is less than 5. And then we have a convenient way of just saying, I want to take this and push this over to the stream. So I'm going to make a qstring representation of an integer. And then let's go ahead and say dash item /r/n, whatever we wanted to put in there for the end of line. Now, because we're working with a stream, we should say we want to flush this down to the disk. We've written some information, it's sitting in a buffer somewhere. Push that down to the actual I/O device. Otherwise, it will do it automatically at a later time, but I want to make sure before I leave this, it's pushed down. I'm going to say file written. Very simple, very easy. Now, did I have to do a set encoding? Absolutely not. It's just going to use the last encoding. I'm just showing you it's very easy to set in encoding. Now, looking at read, you're inclined to believe this is going to be super complex, and it's really anything but. I'm almost embarrassed by how simple this is. So I'm going to say qtextstream. Go ahead and make a stream. We're going to view our file. And then I'm going to, because remember, we're getting a file that's already open. We don't know where we are. We're going to say stream seek. We're going to go to the very beginning. And then I'm going to simply say while not stream dot at end. This should look very familiar to you. We've done this before. We're just going to read this line by line. Oop, not read line into, read line. There we go. It's just really that simple. So what is the benefit of using a QText stream? Well, it's just a convenient interface. It's really a convenience class, and it handles the encoding for you automatically. Think of it in those terms, where if you had to have some special encoding, that was a requirement, you have to have it. QText Stream is going to take a lot of that complexity out. You just simply set your encoding and then pump information into it, and it's going to take care of that encoding for you, and then it'll automatically decode it back. This is just really simple. I love it. Let's go ahead and save run. And as long as I didn't screw up any of the typing, we should work just fine. Ta-da! Encoding is at 0, file written, and we've read those items back one line at a time. This video, I hope, does not hurt your brain, but we're going to switch from plain text to data. This is not human readable data, meaning what we write to a file, you're not going to be able to just open a text file and read it directly. What are we talking about? QDataStream, specifically data encoding. If we pop open the help for QDataStream, you see it is a class that provides serialization of binary data, meaning not human readable. And I'm going to level with you. This just takes everything that we built upon and adds to it, and it's very simple. It follows the same API, and you should easily be able to understand this if you watched all the videos in this section. I've got some code already in here. We have a write function, which of course is just going to open the file in write-only mode and then close it. Notice we're doing all of this in one function rather than passing a Q file back and forth. Just showing you there's different ways of doing this. Read does the exact opposite, where it's going to open it in read-only mode. And then we have a main, which of course is going to say test.txt. Remember, the extension does not denote the data in it. We are making a text file, but we're going to put non-human readable information inside of it. And then we're going to say if we can write to the file, then go ahead and read that file back. Very, very simple. So let's dive in here. And let's just jump right here. I'm going to go ahead and say QDataStream, and we're going to go ahead and give it our file. Again, this API is going to be hauntingly familiar. Now we're going to say stream.setVersion. Notice we're not setting an encoding. We're simply setting a version. I'm going to say QDataStream, Qt. And we have all these versions to choose from. So what is this really? This is really internal to Qt and how Qt stores information. The thing is, they've made subtle changes with each version of Qt. So for example, if you were to write something in 5.7, it's not necessarily going to be compatible with 6.0. So you're going to always want to set that version when you write. That being said, why would we want to use almost, I want to say, a Qt proprietary way of streaming or serializing data? Because there's a bunch of different ways to do it, and it can get very, very complex. But really, we just want to store information, i.e. variables, and then read them back. But we don't want to deal with the complexity of coding that information down to the file. We want Qt to do it for us, and that's what serialization really is we're taking information and we are serializing that and placing it into a file on the hard drive. So now that we've got our version, what we can do is let's make some variables here. I'm going to say int age equals 45. Say qstring name equals Brian, and weight I'm one of those weird body types where I am 185.06 pounds as of this morning. But if you were to look at me, you're like, eat something. You are way too skinny. I'm like 6 foot tall, so 185 makes me look just rail thin most of the time. Unless you look at me via photograph, then it looks like I weigh 200,000 tons, which always makes me self-conscious. But anyways, so now we're going to say stream. They do say the camera adds 20 pounds, but stream, we're going to pump out the age, then the name, then the weight. Notice there's a specific order. When I say specific order, what I want you to focus on is we are defining the order. We want age, name, weight. We could have done weight, name, age, or whatever, but remember the order you do this in: age, name, weight. So what Qt's doing is it's taking this stream, saying, I want to put an int in there. It's encoding it, putting it in, taking a string, encoding it, putting it in, taking a double, you guessed it, so on and so forth. So what can be encoded? Basically any Qt base type. There's some caveats there that we won't really get into because it gets way more advanced in this conversation, but yes, pretty much anything. You just dump it right in there. From there, what we're going to do is I'm going to just copy and paste some stuff, just save a smidge of time. We're going to flush or write that down to the disk, and then we're going to see, was there an error? You're not going to see this too much in the real world. You're not going to see people flush and then see if there was some sort of error. I like to do this just in case, but 9 times out of 10, if you've gotten this far, it's going to write just fine. Then we're going to go ahead and close and return false, otherwise return true. So if we wrote the file, this is where we got to pay attention here. Return true means it wrote. However, if we flush and we were unable to flush, then it's going to return false. So read will never trigger off. Reading, well, this is very eerily similar here. So I'm going to go right here, say Qt data stream, call this stream. You can call it really anything you want. Go ahead and get our file. And now I want to check. This is where me, the developer, would say, if the stream dot version is not what I expect it to be, in this case, we want 6.0, we know that we're going to have problems. So this allows you to easily move the Qt data stream from one Qt version to the next. So what you could do is load everything up and then save it back as a different version if you had to. So if we're not able to do that due to our version information, we're going to let the user know, hey, you're going to have a bad time in version land, wrong file version, file close, return false. Otherwise, if we get this far, it's really simple. I'm going to say int age, and we actually don't even need to initialize these. Qstring name and double weight. You can initialize them if you want to, really don't need to. I'm going to read those in, say stream. And we're going to read the age. Remember when I said remember the order? What order did we put these in? Age, name, weight. So we need to read those back in the same order. Age, and then I can just copy, paste, name, and weight. From there, we got a file close, and then if we really wanted to, we could just output that on the screen. You'll notice one little design choice. I'm close the file, then I'm outputting it to the screen. Because this file is a resource, I want to close it as soon as I no longer need it. So before I do any user interaction, I'm closing that file. All right, let's go ahead and save. And let's run. Assuming I didn't mistype anything, it should just work. File written, name Brian, age 45, weight 185.06. Notice we had 2 file writtens. Where did we get that? Ah, yes. Let's change this to closing file. That way it's a little more obvious what's going on. And let's change this. Little design choice here. Writing file. Save, run, see what's going on here. Ta-da! Writing file, closing file, and then we've loaded it back. Now, Let's play around with this a little bit. Remember I said there's a specific order you got to do this in. So let's play around. Let's grab this and let's try to read this back like so. So now we're changing the order up. Age, weight, name. Let's see what happens here. Notice how we have a problem. That is wow, you'd be your own planet basically at that point. And the name is now confused and it thinks it's just a blank Q string. So what happened there is Q string loaded up, said, no, that's not a string. And it just made a default blank string. This is what's going to happen if you have the wrong order. So if you see something like that, definitely switch that order around the way you had it originally. And remember, your version is important. You should always set your version, that way you avoid any mistakes. Before we close this, I want to go out to the hard disk here and I want to look at that file. Just to show you, what are we at? We're at 813. So let's go into 813. There's test.txt. I'm gonna double click this and you're gonna see something similar to this, or you'll just get, can't read file, and you notice it's trying to figure out the encoding because it's trying to figure out a text encoding. This is what it's showing me is in the file. This is a hex representation of the data in the file. Notice some things it doesn't even try to print out. Other things it tries to take a wild guess what I'm trying to do. This is what I mean by not human readable. You're not going to be able to just open this up and say, oh, that's what it is. But you can see some interesting things. B-R-Y-A-N. Ah, okay. So there is certain things in here that indicate what's going on. So this is not encryption. A lot of people think encoding is encryption, and it's really not. It's just simply encoded. Let's start working with directories. Now, we want to be able to navigate and manipulate them. Notice the keyword manipulate. That's right. We can create them, rename them, delete them, go through them, scan them recursively, slice them, dice them, whatever we want to do, we can do it. But understand what you're doing. You're changing the file system. We're going to cover three main classes at a very high level. QDIR, which of course is a class that provides a directory structure access. There's two different ways of really working with this thing. Basically QDIR and then a path, but notice the Windows path is C/. Let's look at that real quick. Just in case you're on Windows, I want you to be aware of this. If I say QString path equals, and we do something like C path / something, we're going to run into some problems, especially on other computers. Notice it's already complaining unknown escape sequence /p, and then all sorts of other craziness happens. So we're in C++ land. This is trying to convert this to an escape sequence. So instead, you use the other /, and it works just fine. And Qt is smart enough to flip that around as needed. I just wanted to put that little caveat in there for you Windows folks. All right, now QFileInfo. This is interesting. You may be asking yourself, why are we working with a file info in terms of directories? Because it can work with both. Is a system independent file information, but it also returns information about directories. And when I say information, yes, it can do just about any type of information you want. It has a lot of functionality baked into it. So much so that we're probably not going to cover all, and you're going to have to refer to the help file for anything specific you need. For example, like is symlink, is native path, things like that. But you can get things like last modified time, last read, is it an executable, is it a directory, is it a file, the size, does it exist, so on and so forth. And QFileInfoList is just a Q list of, you guessed it, QFileInfos. Very, very simple to work with here. All right, now let's go ahead and say QDIR. And we want to get a directory here. So to do this, I'm going to say Q for application. And I want to know the application dir path. That's going to give us the application's directory path. Where is the application actually located on the hard drive? So I'm going to say QInfo. Well, let's say dir.dir name. Some of these This is something that's always kind of bugged me about Qt. I'm going to level with you. Just trying to figure out which one you actually need is sometimes a challenge. So for example, I'm going to say dir, and we're going to go with the absolute path. Notice there's an absolute file path and then absolute path. File path, you're going to have to give it a file name, where absolute path will take the current qdir. I know that's super confusing, and I apologize. So let's go ahead and run this and see what this looks like. So this is what it's doing here. The dir name is this guy. This is the name of the directory. Now the absolute path is going to give you the entire path of where this is on the actual hard drive. I'm on Linux, so it's going to say slash, which is root, so slash home, root shell code, so on and so on. On Windows, it'll say like C:, wherever you actually put your file. So which one's which? Well, dir name is the shortened, this is just the name of the directory you're in, where absolute path gives you the full path, or the, as the name implies, absolute path of where this thing is. From here, I'm going to go dir.cd up. Notice there's a CD and a directory name and a CD up. So CD stands for change directory. So we could tell it where we want to go, or we could just go up a level. So I'm going to go CD up. And now I want to get that absolute path of where we are now. Let's run this and see what this looks like. So we did exactly that. We went from this directory up a level, and now we're in this directory. So now you can do some basic navigation around the directory structure. It's actually very simple to work with. Now let's say we want to list the directory. Let's say void list. And we're just going to list this out. I'm going to say q info. This is something I'm often asked. How do you list a directory here? I'm just going to say listing, just so we get some separation out on the screen. And I'm going to say for each q file info, let's call this fi, in our root dot. And this is where we got to slow down just a little bit because it's going to get super confusing. I'm going to say entry info list. Notice there's an entry list, which is going to give you a list of strings. We want an entry info list, which is going to give us a list of Q files, which of course is detailed information about things. But the first thing it's going to say is, what filters do you want? Filters get super confusing, and I'm going to just tell you right up front, you're probably going to need to dig through the help file to figure out exactly what you need for your specific instance. But I'm going to use a couple. So I'm going to say qdir. Let's go with filter, and let's say dirs. And then let's go ahead and also say qdir name. Now, when I hit this, let's go back here, you'll see some interesting things like no dot, and dot dot, no dot dot. That sounds like a foreign language. Well, what are these? So in most operating systems, a dot, these dot, it literally is a dot on the screen. It'll look like this, just a dot. That is your current directory, where a dot dot is your parent directory, or the same thing as doing a CD up. So you gotta be a little careful when you work with some of these, because if you're including those in your filter and you're trying to navigate recursively through them, it'll get really crazy results and you can't figure out what it's doing. And then from here, I'm gonna say if fi.is, and notice we got a whole lot of is's in here. Is absolute, is bundle, is dir is what we're looking for, but you could say, is it hidden? Is it a file? Is it this? Is it that? We wanna make sure this is a directory. Then I go ahead and say q info. And let's go ahead and say absolute file path. And remember, absolute's going to give you the complete listing of it here. I know this is a very simplistic example. We'll expand upon that later. All right, now that we've got this, I'm going to go ahead and say, let's list it out and see what's in there. All right, so we have gone up to the parent and we're listing the parent, and sure enough, we've got all of this stuff in there. Notice these are directories. Very cool how that works. Now what I want to do is I want to make a directory. So I'm going to say dir.mkdir, which stands for make directory. We're going to make a test folder. And then I'm going to go ahead and let's list this out again. And we should see that mkdir out there. Yep. There's the mkdir, or the test folder we just did. So that's how easy it is just to build a directory. Go ahead and close that. Now I want to just grab this. And there is two ways of doing this, and I'm going to caution you right now. rmdir is the way to go, because it removes the directory of the specified file name, and the directory must be empty for it to succeed. This keeps you from accidentally wiping out your entire directory structure, whereas if you were to rmpath, you gotta be a little more careful. So removes the directory path. The function will remove all parent directories, meaning it's going to go through and just annihilate everything. And you gotta be a little careful, because that is how you absolutely lose a lot of work, by doing an rmpath or recursively deleting everything that you really didn't mean to. So you gotta be a little careful there. So I'm gonna just put it here as a note, try and save anybody a little headache. Recursive exists, but don't do it unless you capital letters know it should be gone, because you will just destroy everything, and no, it's not going to be in your trash bin. It's going to just be gone. All right, so let's go ahead and run this again. All right, so ta-da, we created our test, and if we go out to our hard drive, and let's look at this. Ooh, there's test. Why did it not remove that? Let's find out. Ah, as we did a make dir, not a remove dir. How embarrassing. There we go. Now let's actually do it. All right. Ta-da, there's our test. And in our second round, it's gone. So now it works as expected. Now, as you saw me kind of goof up on mkdir and rmdir, this is what I mean by you have to be careful when you're working with the file system, especially with directories, because you saw just in this little demonstration how easy it was for me to screw up. What if I wanted to make the dir and I accidentally removed it and it already existed and it had hundreds of thousands of lines of code in it? This is what I mean by be super careful when you ever try to remove something. One question I'm always asked is, how do you navigate a directory recursively? Well, what is that? What does that really mean, recursively? So let's just demonstrate here. I'm going to go out to the file system. I'm just going to pick our folder here. What we're going to do, let's say we're in this folder. We're going to go up to the parent, and then we're going to read every single folder. And inside of each folder, we're going to read every single file and folder. And we're just going to keep going and going until we get to the end of each one. So yes, this is going to output a lot of information. To do that little feat of magic, we've got this function called list, which is going to also call itself. That's right, that's what a recursive function is. It's going to recursively call itself over and over and over again. Now, the major caveat with a recursive function is this can be time consuming. Think about if you did this on the root of your operating system or your C drive if you're on Windows. All of the files and folders in your entire file system are going to get listed. It's going to take forever. So you got to be a little careful when using a recursive function. So I'm going to say for each. And to pull this off, I'm going to say q file info. Call this fi. And we want to get our root, which is just our qdir that we're handing here. And we're going to say entry info list. Remember, if you do an entry list, it's a list of strings. Nothing wrong with that, but we want the full information. wrapped inside of a qFileInfo. Now we have to give it a filter. So I'm going to say our filter is going to be our qdir all entries. We have to be a little careful with all entries because it's going to include everything, even special entries that we don't necessarily want, like that weird dot and dot dot. Let's see, qdir, no dot and dot dot. Oh, what is that? Okay, so remember a single dot just looks like this on the screen. One dot is your current directory and a dot dot is the parent directory. Think about this in terms of recursiveness. So the first thing we're going to do is if we have the current directory and we're doing a recursive function, we're going to scan the same directory over and over and over again for infinity. You don't want to do that. So we got to omit the dot and dot dot. From there, we also want to sort this. So I'm going to say qdir, and let's give it a sort flag, and I'm going to sort this by the name. So this is going to get all entries except for those weird dots, and it's going to sort it by name. This is actually very cool. Now I'm going to just shamelessly copy and paste some stuff in here. So we're going to say, if it is a directory, go ahead and print out dir and then the path. If it's a file, then we're going to go ahead and say print out the file path. Now I'm going to slow down just a smidge. I'm going to say if is dir. Then we're going to do something a little bit different here. Say qdir child. So if this is a directory, we're going to get that directory, say fi, and I want the file path. And I want to let the world know, qinfo, we are now inspecting it. We're going to do something with it. That always happens. I have like the worst luck with that. Inspect it. Maybe I just wasn't born to type. Or I'm just having one of those weird keyboard days. You ever have that where you're just typing and nothing? Gosh, again. Wow, okay. Enough screwing around. We're going to inspect it. And we're going to say child dot absolute path. So we know what we're going to actually inspect. Now, I'm not going to do the recursive part just yet. I'm going to save and run this just to show you what's going to happen. This is just one right here. We're listing, and then wham, that's all the info right here. And then you see where it says inspecting. It's going to go into each one of these folders and list them out recursively. It's going to be a lot of information. To do that, we're simply going to call our function again, but this time with our child. That's right. We're going to grab this folder and say go list it. So the list is going to call itself over and over and over again. That's a recursive function. Major takeaway before we run this is you want all entries, no dot and dot dot, or it's just going to list itself over and over again. We're sorting by name, we're calling recursive. And voila. That is a lot of information. That's everything in that directory structure. And we can just scroll up, probably scrolling faster than the video recording is going to keep up with, but that's the point. This is a lot of information, but if you wanted to process some directory structure, say you're looking for a specific file or you want to read each file or do something, this is how you would do it. You'd simply do a recursive function, and then you would do whatever you needed to do. Now we've kind of skipped over qFileInfo, but let's look at it a little bit deeper. And the problem with qFileInfo is it's just a lot of information, and you may not need a lot of information. So we're going to really drill on some specifics here. So first things first, we have a list function that's taking a qstring path, and we want to be able to work with that. So I'm going to say list qdir, and we're going to go ahead and say temp path. In case you're wondering what that is, well, let's look at it. This returns the absolute path of the system's temporary directory. Every system, or I should say most system, has what's called a temp directory. This is virtually a dumping ground for applications. Now, you should know on Linux Unix systems, this path is in the tempdir environmental variable or /tmp, Windows, I think it's like C Windows something something temp. But if you go out there, and let's actually go out to our file system here. There it is right here. You can see there's a bunch of things in here we didn't create. There's like a Mint update, there's a Qt creator, there's all this configuration stuff. These are other processes creating temporary files. And the whole point of the temp dir is they can just write a file and forget about it. Eventually, this will get cleaned out. And they don't necessarily have to worry about cleaning that out. So it's a very common, yes, a sloppy, but common practice to use the temp directory. So that is how you get the temp path. Now, I typically don't like working with the temp path just because it is, for lack of better terms, the Wild West. I mean, anything can really happen out there. So if you're going to work in the temp path, you should use a file name you know no one else is going to use. All right, so we're just going to list this path out, and I want to go ahead and make a qdir using that string. Now let's go ahead and get a file info list. So I'm going to say q file info list. Call this dirs equal dir dot, and we want the entry info list. And we've done this before. We're going to say qdir all entries. We're smart enough to know we do not want that weird dot and dot. So I'm going to say qdir no dot and dot. Now, notice what we've done, all entries. We could write some crazy function to go through that, or we could do something like this and instead say dirs. Now we have just a list of dirs. Let's go ahead and copy and paste, and let's call this files. I'm just showing you there's different ways of doing this. Of course, we can say files. And because files don't have a dot and dot, we don't really need that. Now I can simply say for each file info fi in our dirs. Let's go ahead and say q info. And we're going to say file name. Very simple. We're just going to take our directories and list out the names. Now, if we wanted to, grab this, grab that. We're going to do this, and I'm just showing you how easy it is just to swap that out because it is an entry info list or a Q file info list. It's got the same information. And then I'm going to paste some information in there. So files, we're going to get the name, size, created, and modified. Very, very simple, very easy to understand. And then from here, if we really, really wanted to, we could recursively do it. So we're going to just say list the fi or the file info absolute path for each and every directory. So what we're going to do is not for the faint of heart, and this could actually crash our application if we lack permissions to something. So for example, if we go out to our file system and we go to temp, you notice there's some things that have this little lock in here, which it's asking me for a password. So this is where I need to slow you down and say, expect issues. Something wrote this and has locked this down with special administrative positions. In this case, systemd did that. So I would have to switch over to an admin or sudo into that and run my application under sudo. If you don't understand what sudo is because you're on Windows, don't worry about it. It basically means you'd have to run with elevated privileges. So we're going to get up to a certain point, and then this simply just won't work. All right, notice how it just stops. We got the information, we're listing temp, and then it goes and goes and goes and goes, and I'm going to actually close that. And I'm going to qinfo this out. We should see done at the very end there. See, done. Now, if you were expecting this to explode, I'm sorry to disappoint. What's going on here? You see how it's trying to list it, but it's getting nothing back. That's built in by design to keep this from crashing, but I want you to note older versions of Qt may crash. 6.0 and 6.0 and newer, you shouldn't crash, but some operating systems will actually shut your application down. Your app may crash. So that in a nutshell is how you would list things out. I want you to be very careful though when you start working with the file system, because you will run into all sorts of crazy oddities. So as we progress through this section, we've gotten bigger and bigger in the scope of things that we're looking at. We started with the file, we went to folders, now we're going to look at mounted volumes. Just a refresher, volumes are a part of the partition. The partition is part of an actual hard drive. We're going to use QStorageInfo to access that. See, provides information about the currently mounted storage and drives. Notice they're two different things. Storage may not necessarily be a drive. That being said, let's go ahead and take a look. I'm on a little Linux virtual machine here, so you're probably going to see something different. So for reference, this is what I got. I've got a little 27 gig virtual hard disk, got one partition with some volumes in here, and this is the master boot record, meaning this is where the operating system boots from. All right, so without further ado, let's grab this. We can do some really crazy things. So for example, I can say root equals root. Now what is that? We're going to get a QStorageInfo that is a representation of the root. And if you're on Windows, root may be a weird concept for you. But basically, highlight F1. On Unix, Linux, it returns /root. On Windows, this is where the operating system is installed. So the root is basically, where is your operating system? Where is this thing booting from, essentially? And yes, I'm aware there are multiple ways to boot a machine, and that's not always true, blah, blah, blah. But just think of it in those terms. That's where your operating system's usually installed. So I'm going to say qdir. That's one thing that's super frustrating about computers when you get into it, is everything can be different. All right, so we're going to say root path. We want to know the actual path here. Now, this is actually very underwhelming. I'm going to just QInfo this out just to show you how underwhelming this is. You already know what it's going to be. So I'm going to say QInfo. And let's just go ahead and run that, just so you can see what root path is going to look like here. And yes, underwhelming. It's just slash. If you're on Windows, it's going to be like C or whatever you installed your OS on. All right, now we've got our dir. And let's go ahead and for each. And we're going to say Q file info. FI, I'm just kind of whipping through this because we've already done this. Entry info list, we're going to say qdirs. And of course, we don't want that dumb dot and dot. And then we can just list out the QInfo fi dot, and we want the file path. So really all I'm showing you here is that you can get the root or the heart of your OS and then just list out the things. And when I say the things, could be what you want. I'm doing dirs, but you could do all entries, files, whatever. So let's just save and run. And ta-da, there is everything listed off the root of the operating system. Yours, of course, is going to look different. If you're on Windows, it's going to see C drive and then all your folders in your C drive. This is very cross-platform, and it's something I absolutely love about it. Now I want to show you something that is going to be very different depending on what computer you run it, and you're going to see a lot of weird things. So I'm going to say for each QStorageInfo. And I should say this is very operating system dependent is what you're going to see. So I'm going to say QStorageInfo, and I want the mounted volumes, meaning list all the volumes that the operating system is currently working with. And actually, I'm going to put that at the end here. I don't know why I put it up there. And I'm just going to say QInfo, and we're just going to put a little voila. All right, now a little copy and paste action just to save a smidge of time because no one wants to sit and watch me type all that out. Really, all we're doing is we're going to go through the mounted volumes. Keyword mounted. The operating system has to be interacting with this. We're going to get the name, the type, because you can have a different file system type. We're going to get the total bytes in megabytes, the available bytes in megabytes, the device, and is it root? Now, because I only have one hard disk, you're inclined to believe it's going to be very small, but watch this. Notice we get a lot of different things. All right, so there is our listing of our file system, and then we're going down and we got /run. This is a temporary file system. It is 834 megs, and it is not the root. And then we have our root, ext4. It is on dev SDA5, and it is the root. So we know that's where our operating system is. And then we have a run lock, we have a boot EFI, and so on and so on. And you're going to see different things on different computers. But I wanted you to be aware, if you, for whatever reason, need the mounted volumes, that is how you would do it. Let's cover a weird situation, because let's face it, you're going to be asked to do some weird things. How do you lock a file to one instance? And what are we really talking about here? Well, we're going to use QLockFile. It provides a locking mechanism between processes. Have you ever seen that where you have, let's say, multiple copies of the same program running, but if you go to open it, it's going to say, oh, this is locked by some other user. That's exactly what we're doing. We're implementing that mechanism. And that was really indicative of like Microsoft Word or MS Access or some of the older programs, but that locking mechanism is still used by applications today. Now, I'm going to do a fair amount of copy and pasting in here because, to be honest, we've covered a lot of this and there's no sense in sitting here watching me type for 20 minutes. So what we're going to do is I'm going to first just do the old copy paste. We're going to say attempting to lock file, and let's just, so we're going to get a path. And we're going to say we want the QDIR current path and then the QDIR separator. You always wondered how it knew the difference between, say, a Unix separator or a Linux separator. That's exactly it with test.txt. Now we want to put that into a Q file. Now what I'm going to do is I'm going to say QLock file, lock, and now I need to give it a name. So we're creating a second file here. And I'm going to say file dot file name with an extra L. So out in the directory, you're going to see test.txt and test.txtl. You're going to see two separate files. So we have the file we're working with and a lock file, which denotes, hey, we are currently working with this file. This thing can get crazy confusing if you let it. So try to just stick with the basics when you're working with this thing. So I'm going to say lock, and then we're going to set the stale lock time. Okay, that's an interesting one. I'm going to set that to 3 seconds. Let's go ahead and look at the stale lock time. Basically, this is when the lock on the file is considered stale or we forgot to unlock it. The default is 30 seconds. Your application typically keeps a file locked longer than 30 seconds. You should set a bigger value. Basically, we want to give the outside world a means of getting into this file somehow. We don't want to keep this locked indefinitely. Now I'm going to simply say if, and I want to say lock.trylock, meaning we're going to go ahead and try to lock that file. And if we're not able to lock it, we want to do something completely different. And this is where copy and paste is going to really be our buddy here. There's no sense in watching me type this out for half an hour. It'd be probably 30 seconds, but still. So we're going to get that lock on the file, and now we can work with it. We're going to write only. We're just going to put some information in there. If it took over 3 seconds, we're going to auto unlock it. And then we are going to manually unlock it, and we can comment this out to keep it locked. And I'm going to probably bump this time up. Let's bump this up to 15 seconds. I'm going to say it took over X seconds. When we're done, we want to unlock. So if we're doing something here, it's going to keep that locked. We're going to comment this out and see it in action. However, if it's locked, then we want to know what's got it locked. So we couldn't lock the file, and we're going to get the PID or process ID on the host and the application. That's right, because you can have the process on different hosts. So we want to know the process, the host, and the application, and we're going to say, hey, the file is locked. This is actually kind of neat. So let's go ahead, save and run. Ta-da! So attempting to lock file, putting into file, finish with the file, unlocking file. Now when we go out to our directory, you're instantly like, well, wait a minute. Weren't there supposed to be 2 files? Well, there were, but we finished our file operation and everything is good. Now, notice how we don't have any data in there. That's going to bug me. So let's just say data dot and hello world. That way we know we're actually writing something to it. Do that again, just to see. But again, it's working just fine. We can run it multiple times. And now our file has hello world in there. Now let's play around with this. Let's comment that out. Save and run. Let's see what happens here. Okay, so it says unlocking file, but we forgot to do that. And there is our test.txtl. Here's our actual little lock file. And if we open this with the text editor, ooh, what do we got here? So we have a process ID, we have the process, we have the box, and then we have some information here. So this is telling us, information about the lock. We have other copies of that application. So the major takeaway here is we can run multiple copies of this application. So let's do that. I'm going to actually delete both of these. And we're going to run this. Now we have it, and it's going to be locked, but we never unlocked it. Now let's try and run it again. And here we go. Here is our original process where we locked and forgot to unlock it. And then here we're attempting to lock it. And it says it's locked by this process, this guy, on this host, which is our virtual machine. And the application name is, ta-da, that. That's what I mean by it gets very simple. It's an easy mechanism. So if you want to be able to use a file in the same application across multiple users, qlock file becomes ridiculously easy. Now, after so many seconds, this thing should auto unlock itself. I say should, but let's find out. I'm going to actually close this down right here. And let's just test this. We're going to go to date time settings, see if I can get a clock up here. Oh, of course not. I was looking for an analog clock. Close this. Notice it's still locked. We still got this in here. I think we've been talking for longer than our lock time here. Let's go ahead and try that. Do this correctly and see if it will unlock it. Yep, so we were able to do it. So what happened there was the stale lockout timer had hit and we were able to reopen that. And if you want, you can go ahead and skip the rest of this video, but I'm going to demonstrate that again in case somebody's like, wait a minute, it didn't make sense. So we're going to forget to unlock the file. Let's go ahead and save run. Ta-da. And now we have our lock file back in here. And I think we have it in, where was it? 15 seconds. Yep, right here. And we can just, 1, 1000, 2, 1000, 3, 1000, 4, 1000, 5, 1000, 6, 7, 8. I'm probably counting faster than time's going on. Blah, 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 blah. Just going to waiting. Let's see. And we're going to leave this bad boy open just to see what happens. I'm pretty sure more than 15 seconds has gone by. So let's go ahead and run this. Oh, no, it's still locked. Ooh, that is frustrating. Let's try and run it again. See what happens. Still locked. But what happens if we don't change the code and we simply close the file? Magically, we can open it, even though that lock file is still there. Why? Because it's detecting the process. It's going out and saying, oh, the process is still there, therefore the process still has a lock on it. At least that's what it's trying to figure out. I am a huge fan of making something that's complex very simple. So what we're going to do is we're going to intercept QDebug messages. Why? Because we want to be able to catch those messages in real time as they happen and put them into a log file. So I'm often asked, QDebug, like QInfo, QDebug, QWarning, all these messages, where do these actually go? What's the difference between, say, this and the standard output? Well, they actually, under the hood, I do believe, use the standard out and standard error. So when you run this, let's just go ahead and say run, you see it actually out in the standard output and the standard error. That being said, we have our QFatal, which crashes our application. Show you right here, QFatal. Now, I'm sure you've run into this before where you give a program to the end user, they run it, and then they come back and they go, oh, well, it crashed. And you say, what was the error message? And they go, well, I don't know, the screen's gone. Well, now you've got to try to reinvent the wheel or recreate the situation that they did that made the application crash. Because it's always the end user's fault, right? It's never us, the developers. But anyways, so it would be super, super helpful if we could intercept these and put them into a simple log file. Now, it's a little tricky, but if you just mouse over this, it tells you some things about how you can intercept a message. And it's almost impossible to see, but if you're really quick, you can do it. So instead, we're going to say q install message handler. And we're just going to highlight that and hit F1. And really what this is going to do is it's going to intercept any QDebug message, whether it's an info, debug, warning, critical, fatal, so on and so on, from anywhere in the application and allow us to do something with it. So what we're going to work with here is a function pointer. So we're going to tell this use a specific function, or as the documentation says, do a null pointer or a 0 to set it back to default. So they even give you the code. This is ridiculously simple. I absolutely love this. You can literally just copy and paste this code into your app and it works just fine. It shows you a complete application on how to do this. But not many people know how to do it. You just got to kind of figure it out. So I've already got some code written and ready to go. So we're just going to copy and paste. There's no sense in watching me retype all that. So from the top, we are saying const Qt message handler default message handler is actually going to be a Q install message handler null pointer or 0, meaning we're setting this back to the default message handling. Ah, okay. Now we want to say L handler. This is our function, and we're going to follow this specific set of parameters right here, because this is what Qt's going to give us: a message type, a log context, and a message. And from here, we're just simply building a string, and this, in case you're trying to follow along, it's the same code they literally gave us. I just modified it slightly. We're going to say if it's an info, just print info. If it's debug, print debug warning, and so on and so on. But at the very end, all I've done is what we covered in the last section. File system. I'm making a log file, log.txt. We're going to open that in append mode so we're not overwriting our log. We're going to use a QText stream so we have the proper encoding. And then we're just going to pump out the date time, the actual message, the context file, and the context line. Then we're going to flush it, make sure it gets written down to the disk, and close the file. And then, of course, we're going to Qt default message handler, pump that out. So what we're really doing here is we're capturing this information, and then we're saying, hey, Qt, go ahead and pump that out the normal way. Seems complex, but it's actually rather simple. Let's see it in action. So we're going to grab that L handler, and voila. It's really that simple. We're just going to simply install the handler, and from any point after this, it will go through our logging system. Anything before will not get captured. Just to prove, let's go ahead and go into our build folder. There is no log.txt out here. So let's go ahead and save run. All right. Info, debug, warning, critical. This is Sparta. Our application crashed. Oh no, we lost the message, but guess what? Now we have a log. Let's open that bad boy up, and sure enough, there it is. This is just beyond simple. So we have our date time, we have the info, debug, warning, critical, fatal, and oh, this is awesome. It actually has the file and the line. So we have detailed information of exactly what happened. You can put virtually anything in here, and it just works. It's that simple. All right, if you skipped the last video, I highly suggest you go back and watch it. It was short and it was simple and to the point, but we're going to take that code and improve upon it. We're going to make a logging class that will log from anywhere in our application. I have two classes in here. I have logger and test. These are just very blank Q objects. I just made them. There's no code in them at all. See, ta-da, ta-da, and our main file. So let's go ahead and flesh this out here. The premise being our logger is going to do a lot of the heavy lifting for us. So what we need to do now is just add some includes. And there's going to be a whole lot of copy and pasting in this video just to save some time because it's all stuff we've already covered. There's no point in recovering it. QDebug, QFile, QDateTime, QDir, IOStream, and QTextStream. Now from here, we need to do a little bit of explaining. So we want this to be used statically throughout our application, meaning we don't want to have to go ahead and create an instance every time we make a logger because then we're going to have multiple loggers and all sorts of issues. So we're just going to say static bool logging, static QString file name. We want a static function attached, and then we want our static handler. Let's go ahead and right click and refactor. We're going to add that in. And then right click, refactor, add that in. It's actually very simple at this point. We just simply need to do a few things. First thing, we need to implement, you guessed it, our static variables. So we're going to say the logger file name equals their current path with separator and log. We could have just said log.txt, but I wanted to make sure I explicitly said the path. And then we want logging equals false by default, and then we're going to just set our default handler to Q install message handler with null pointer. Again, this basically turns that off. You can hit F1, and this is the code they use to show you how to intercept that. As long as you're using this right here, this is actually the simplest thing you'll ever do in Q. I feel bad almost describing it because it is just that simple. As long as you're using this signature, you're perfectly fine. So from here, we're going to do two quick things. We're going to say logger logging equals true. And then we're going to say Q install message handler. And let's go ahead and say logger handler. So all we're doing is saying, yes, we are logging, and we want to install the message handler using this guy right here, which is a static function, and it will work just fine. From there, I have slightly modified, and I'm just going to copy and paste it in there, that code. So all we're doing is we're saying, if we're currently logging, go ahead and snag this and drop it into a file using the loggers file name, that static variable we put out there. And then go ahead and flip it back to the default so we can see it out on the screen. And everything should just work exactly the way it did in the previous video. It's really just ridiculously simple at this point. Let's go ahead and save. Save. Give it a build just in case, just to make sure we didn't goof anything up. And then let's go ahead and go into our test class. This is just simply going to be a test Q object just to prove that we can snag those messages from basically anywhere in our app. So I'm going to say void testing right click, refactor, and ta-da! I'm just going to put a warning in here, and I want to put a QDebug in the constructor just to kind of show, it doesn't really matter. As long as you've got that message handler installed, it's going to grab these in real time as they're fired off and pump them out to the log file. Now, for something more production, you should actually do something a little more robust. Like, you notice how we're opening and closing this file every single message. That's going to get really hard on that hard drive. It's going to, I mean, if you have a production level app, it's going to start thrashing that hard drive really, really bad. So you may want to actually open this by like a start logger and then close it by a stop logger kind of function. Just wanted to throw that out there. I've had a few people try using this example in production apps, and it did not end well because guess what? They were thrashing hard drives all over the place. So we're creating a logger. Why? We want to intercept all the messages, and we want to move the handler into a class here. We've already done all of that housekeeping. From here, it's just a matter of, well, you guessed it, making it work. So I'm going to say QInfo. We're going to go ahead and say file. We just want to know what file this is going to log to. We'll say logger file name. Let's go ahead and attach our logger. I mean, before we really do anything else, but you notice we've already fired off a message. We have not attached the logger, so that's not going to go into our log. Go ahead and attach. Now, if we look at attach, just right click, switch header source, or actually let's follow symbol on a cursor or F2. What we're doing is we're setting that bool to true, and then we're installing that message handler right here. So now we're saying, hey, once we attach, we're going to start logging. And then just as a test, I can say QInfo test, just so we can see, what it is. And then I'm going to turn it off. I'm going to say logger logging equals false. I'm going to say this will not get logged. Let's go and turn it back on. Logger logging equals true. The point I'm really trying to drive home here is it is really just ridiculously simple to work with at this point. We can even use a class. And let's go ahead and finish this out. Now, I know I did a lot of copy and pasting just to save time. If you're ever really, really super confused on where I got that code, really jump into the help system and look up the Q install message handler. You can just highlight it, hit F1, and it really details out. There's really no sense in typing all that out over again when we already have the code and copy and paste it. The main takeaway from this video is we now have the ability to turn logging on and off at will, and we can grab those messages from anywhere in the application. Let's go ahead and see it in action. So I'm going to go ahead and give this a good build. And let's run. All right, so this is our log file right here. We're testing. This will not get logged. Pay special note to that because we did disable the logger. And then we have constructed, this is a test, and finished. So let's go ahead and jump out to our hard disk. All right, so here is our log. And if we bring up our app at the same time and kind of move it off to the side here, you can see there is our file. We've actually created that. And then warning, this is a test. Notice right here, there is this will not be logged. You don't see it in the log anywhere. It's because we disabled that. Let's pop open the code. Logging false. This will not get logged. It's not in our log file at all. So that's a very quick and dirty, simple example of how to make a very fast logger. Now, the major takeaway from this, I really want to highlight again, just in case, is if you're going to use this code, you're going to want to basically open and close the file at certain intervals. Meaning don't just open it and then close it on every single write, because you're going to be constantly opening and closing that file if you've got a lot of messages. Let's take a look at something that, well, a lot of people either don't know it exists or just simply don't use it because they think it's too complex, but it's actually fairly simple. We're talking about categories. Meaning we've looked at different levels, i.e. something like info, warning, debug, so on and so on. But now we want to make categories like network, hard drive, user, but we want those levels inside of each one. This gets a little bit complex, and admittedly, the documentation could probably be spruced up a little bit. We're going to use Q logging category, and there's a few things in there we need to pay attention to: the declare logging category and logging category, along with set filter rules. And if I went through that very quickly, it's because you can just simply include Q logging category, highlight it, hit F1. Voila, there's all the documentation. Makes it very convenient, very easy to understand. So the first thing we need to do is actually declare and then define the logging categories. So let's go ahead and do that. We're going to say Q declare logging category. And very long, but IntelliSense helps us out. So we're declaring this thing is going to be a category, and we're going to call it network. You may be wondering what this actually does. You can simply hover the mouse over it, and it gives you pretty much what we're doing. We're defining a logging category using extern const q logging category and name. So it just simply declares that it's going to be a thing we're going to use. Admittedly, that's a little vague. Now we're going to say q logging category, and we're going to set our category network with a human readable string. I like to do the same just so it's very easy to understand what's happening. So the string aligns with the declaration. They're the same thing. Now this is a source of a lot of questions. What's really the difference between the two? And this is where I think the help system could be updated a little bit better, but we highlight declare. It declares a logging category name. The macro can be used to declare common logging categories. That's really all it does. The macro just declares that it's going to be there. But if we go to logging category in F1, it defines it. So that could probably be overly simplified into, you guessed it, all in one kind of statement. That being said, let's go ahead and see how this works now that we have declared and defined our category here. Let's go ahead and say q info. Now, what I want to do is say q info, and we want to use our category here. So our category, of course, is network. And let's just run this and see what the difference between the two really is. Aha. So without a category, it's this, and with the category, it says category, semicolon, and then our message. So now we can easily define different categories and still use the levels. So for example, we could, if we wanted to, grab this. And let's instead be warning. Save, run. Works as expected. All right. Now let's try and turn that off. Now, what do I mean by off? Meaning we do not want to see anything in that category. So I'm going to say q logging category, set filter rules, and notice it takes a string. I actually am not a fan of when APIs are a string, because then you've got some magic string you need to go look up, but it's actually baked right into the help system. Just highlight this F1. It tells you what the rule system is a whatever it is, and then the debugger release, and then true or false. So in our case, it's network. And now we want to know if we want this in debugger release mode. You can see over here, we are in debug mode. You could always flip over to a release or something else, but we're in debug, so we're going to say debug. And now we need to turn that off. So even though it's one of those magic strings, it's really not that bad. All right, so let's test this now, and I'll say will not log, because we want to just very simply, very easily understand it's just not going to work. I'm going to say kitty, and let's go ahead and put our category in there. Save, run, and let's see this in action. Notice it's not going to show because it's set to false. So now you can define a category, I should say declare a category, define a category, turn it on or off through filtering. That's actually extremely powerful now that you think about it. You can build a pretty robust little logger here. And then you can actually do things like this. Let's go ahead and say if, and I want to know if the network is debug enabled, meaning have we previously set a filter rule? Queue logging category. We're going to go ahead and set the filter rules. And we're just going to grab this thing. And flip this over to true. And then we can just say something like queue debug, and actually just going to grab this right here. Very simple, very easy to use. We can just simply flip it back on. And we actually should put if network is not debug enabled and run this. So test, we turned it back on. Notice we're not seeing Kitty because we disabled it right there. And this just works. It's actually pretty smooth, pretty easy to understand. Now, you may have noticed as I was typing, we get this little object here. Where did this come from? Well, that is from our declare and logging up here. And it is a queue logging category. Now, if you try to F1 on that, it's going to say no documentation available because it's looking for the actual name, which is this class right here, queue logging category. Very simple, very easy to understand once you really get the intricacies of this, but a lot of people don't use this. And it's a shame because I actually think it's fairly easy to work with once you wrap your head around how it actually works. Now, the last video, we looked at queue logging category, and the examples we gave were a little bit verbose and a little hard to wrap your head around. So we're going to make this easier. That's really the goal of this video. We want to make logging categories easier using queue logging category. So first thing I'm going to do is just grab that. And let's call this log test. So what have we really done here? Well, we've defined our own logging category, meaning we've kind of done away with those macros. We don't want to deal with those. They work, they're great, but they're a little confusing. Now I'm going to grab log test here and say set enabled. And we're going to enable, you notice it wants a Qt message type. So I'm going to say Qt message type, Qt debug. Let's go ahead and set those to false. Remember, if you're ever confused whether you're in debug or release, it's just simply right over here. You click this, we're in debug. We could flip over to release just by clicking it. It's really not super hard now that we figure out how this works. We've got our category. We can set the enabled, so we can turn it on or off really quickly without using some magic string. And then we can, if we wanted to, the power of copy and paste here. We can say QDebug, and then we want to know this category is debug enabled, info enabled, warning, critical. And then let's go ahead and use that. Now we've got QDebug using the log test category, and then info, warning, critical, and so on. So we've now overly simplified the last example. Let's go ahead and run this and see what it looks like. So you notice right off the bat, we have disabled debug. Debug's false, but info, warning, and critical are true. So we see the info, warning, and critical. We can, if we wanted to, flip this back over to true or just simply comment that out because it's true by default. It's actually very simple to use a logging category once you understand how simple you can make it, which honestly, I don't know how to make it simpler than this. I absolutely love using this method. This section is all about encoding. We're going to start with the lack of encoding. We're going to start with ASCII, and you've seen this before. You work with it all the time. ASCII is just the American Standard Code for Information Interchange. Basically, letters, numbers, things that you see on the screen. If you're used to English, you've been using ASCII your whole life and never realized it. So it's 0 through 127, and each number corresponds with a letter or a character or a number. Now, some of these are non-printable. So for example, if you open up a Word document and hit the space bar 100 times and then print it, you're going to get a blank piece of paper because the space is non-printable. All right, so without further ado, let's look at it here. So ASCIItable.com, in case you're curious, ASCII is a 7-bit character set containing 128 characters. Let's just dive in and really look at this real quick here. There's not a whole lot to see, but I want you to really understand the fundamental concept that a number really correlates to a character. So I'm going to say make data. I'm going to make our little function here called make data. And this is where I'm just going to do the old copy paste just to save a smidge of typing here. So all we're doing here is we're saying qbyte array data, data append. And notice what we're doing here, appending numbers 72, 101, 108, 108, 111, 33, 13, 10. But notice I put these are non-printable. 13's carriage return, 10 is line feed. So when you hit the enter key on the keyboard, especially if you're on a Windows box, it's going to do 1310. Now, what you should really note here is what we're doing. We're intermixing printable and non-printable ASCII characters. Now, in case you're going, wait a minute, how do I even know which one of these is which? Well, that's where the complexity lies in. So you have a number. That number correlates to either a hex or an octal value, which actually represents a character. So let's just pick one. Let's say 108. We got 2 of these. 108 is the letter L. Might be microscopic on my screen, and I apologize, but that is the letter L. So in case you're curious, let's just figure out what this says here. Let's go ahead and do a qbyte array data equals make data. And let's print that out and see what it looks like. All right, so we have hello, 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 over and over and over again. That's just ASCII. Now, notice on the screen, it's showing this carriage return line feed, and that's because we are using, you guessed it, Qt with Qinfo. Had we done a cout, it would have done different lines. So what we're going to do now is dump this to a file, and we've done this before, so it's really not super hard. Say data.txt, and then let's simply go. Actually, I want to do if file.open. We want the QIO device of write only. Then let's say file.write. We're going to go ahead and write that data. Notice what we're not doing though. We're not intermixing this with a QString. There's a reason for that. So QString is going to automatically convert it to UTF-8. So QString is going to change from ASCII to UTF-8. The good news is they are interchangeable up to a point. I should say up to 127. All right, so the main point I'm making here is we said 108 was the lowercase l. Doesn't matter if that's ASCII or UTF-8, it's still lowercase l. That's what I mean by it's interchangeable at the numeric level. So we're going to create this file, data.txt, save run. Let's see what it looks like. All right, so we've written our file. Let's go out to our directory here. And there's data.txt right here. Ta-da! That's it. It's just simple. It's just ASCII. This is stuff we're used to. But this is what I'm trying to tell you right here. The world is much bigger than just English. we have many languages, and some languages actually have pictures as character. Like if you've ever seen, and I know I'm gonna say this badly, but some Asian languages almost look like they're beautiful pictures to Americans because we don't understand the letters. Those are simply not in the ASCII table at all, which is why we need other encoding standards. Let's take a look at UTF-8. This is more complex and it supersedes ASCII. It is up to a certain point compatible with ASCII. Now, when I say up to a certain point, I mean the first 127. Everything else is not compatible with ASCII. So UTF-8 is a variable width character encoding capable of encoding this large number way beyond 127. This is a 1 to 4 byte character unit, meaning it could be 1 byte, it could be 4 bytes. It gets more complex as we get into this higher range. Now, why do we want this? Because we want to work with non-English languages. I have a little function here called make data. You'll notice it uses a QString and it's going to return a QString and it's just going to say QString data append Unicode test. So nothing so far looks out of the ordinary. Now I'm going to do something, well, you would for no reason ever want to do other than this probably very simple example. We're going to go ahead and say for I equals 0, and I is less than 10. Let's go ahead and increment I. We are going to randomly generate some characters here. So I'm going to say int number. I'm going to use the Q random generator. We want the global random generator, and we want to do bounded. So what this is going to do is give us a range, and we're going to go from 0 up to this number right here. And we got a subtle bug. We're going to switch that to a 3 because it's a 0-based index. So we want to be able to randomly generate basically anything in UTF-8, which goes way, way, way beyond what ASCII could possibly handle. Then I'm going to say data.append, and I'm going to make a QChar. And we're going to plug that number in. Now you may be going, no, wait a minute, what is a QChar? Well, strings are made up of characters. So remember, anything that starts with Q is part of Q. So we are making a character that goes in and creates a string once you have a bunch of them together. So let's look at QString. QString provides a Unicode character string. Okay, so we're already working with Unicode, and we've been working with it this whole time. QString stores a string of 16-bit QChars, where each char is responsible for one UTF-16 unit. So QChar itself is also Unicode. So we've been working with Unicode this entire time. Now, I'm going to say it, back in the day, Unicode was a royal pain, but it actually exists for a reason because we have to support every language out there. So I'm going to say QString data equal make data. Let's go ahead and print this out and see what it looks like here. Save and run. And voila, this is what Unicode looks like. And every time I run this, it's going to be different because of that random generator. So let me just run it a few more times. You can see as I'm running this, it's changing because of that randomness. But what you're also seeing is non-American characters. I don't even know what language that is. I'm very ignorant. I would probably say it's Japanese or Chinese, but it's probably like Korean or something like that. So anyways, point is, we have normal printable characters, we have escape sequences, we have this little guy, this U. This is a hex representation of basically Qdebug couldn't figure out how to print it, so it just did a hex representation. And then we have some Asian characters. This is actually extremely powerful. Now we have a much broader range of characters to work with here. And if we really wanted to, I'm going to just go ahead and copy. Let's paste some code in here. We've already covered how to work with files, so we're going to say file data.txt, file open. We're going to go ahead and write only. We're going to open up a text stream, and I want to point out we are setting the encoding to UTF-8. QString is automatically Unicode, but we are forcing this text stream to use UTF-8. We really don't need to do this. Stream, we're going to pump that data out, then flush it, and close the file. Now, One thing I want to note, we are going to get the question time and time again, is how do you convert back to ASCII, ASCII? Well, we're going to take this data, this Q string, say to Latin 1. But there's a problem. If we look at to Latin 1, documentation on this is going to explain it very elegantly. Returns a Latin 1 representation of a string as a Q-byte array. However, returned byte array is undefined if the string contains non-Latin 1 characters. Those characters may be repressed, or I should say suppressed, or replaced with a question mark. Question mark, meaning we're going to lose data, and you're going to see that very quickly here. So let's go ahead and save and run. And there we go. So our Unicode test, this is what it looks like as UTF-8. And ASCII, of course, we have lost data. We just have a bunch of question marks for anything that was outside of the ASCII table. Now, if we go out to our hard drive, and let's go ahead and look at this file here. And we want data.txt. Ta-da! You're going to get different results depending on what you open it up in. Some Notepad style applications simply can't handle Unicode. They're expecting ASCII and they simply won't work. But yeah, this works and I actually like it. It's very simple, very easy to use. And from the standard of Qt, having UTF-8 or Unicode baked right into your app is a huge win. Let's take a look at UTF-16. Now, a lot of people get confused when they're learning this and they go, wait, whoa. What's the difference between UTF-8 and UTF-16? Well, notice the difference. 8, 16. That means 16 uses 2. So we want 1 or 2 16-bit code units. This gets a little bit misleading. But remember, what we're doing is we're actually using more information. UTF-16 is a character encoding capable of the same amount of non-surrogate code points. The encoding is variable length, as the code points are encoded with 1 or 2 16-bit units. Still didn't really answer the question, so of course, Stack Overflow to the rescue. UTF-8 has an advantage in the case where ASCII characters represent the majority of the character blocks of text, because UTF-8 encodes these into 8 bits, just like ASCII. Yes, we're talking nuts and bolts C++, the things you probably kind of just, daydream through during class like I did. But anyways, UTF-16 is better where ASCII is non-predominant. So really what we're saying here is we can have UTF-8 for backwards compatibility with ASCII at some level, like we showed in the previous video. But if we don't care about ASCII at all, UTF-16 is a much better choice, since it uses 2 bytes per character. UTF-8 will start to use 3 or more bytes or higher for higher order characters. This gets really confusing, but really what we're talking about is data size. Everything we're using takes up memory at some level. So it really boils down to UTF-16 is a little bit more streamlined than UTF-8, but UTF-8 is a little easier to work with ASCII. I don't know about you, but I don't want to worry about any of this complexity. It just seems backwards and it hurts my brain. So let's simplify it. We're going to take literally the same code we had in the previous video. And in case you skipped it, all we're doing is we are making a Q string, which is going to use some randomly generated numbers that are bounded in a range. I'm going to fix that small little bug because that could potentially crash it. Data append qchar, and this is all Unicode, simply returning a string. Now we're going to pump that out to a file. This is a QText stream, set encoding, and from UTF-8, we're going to switch to, you guessed it, UTF-16. It's ridiculously simple working with Unicode in Qt. You don't need to sit here and reinvent the wheel. You just switch your encoding from 8 to 16 and you're good to go. Let's go ahead and run this. It's going to look very, almost eerily similar to the last example because it's virtually the same code. Again, 16, if we try to work with ASCII, it's going to blank that out in question marks. Now, someone out there is going to say, no, wait a minute. Aren't we working with 16? So couldn't we see the UTF-8 version of that? Absolutely. Let's demonstrate that. So we're going to say to UTF-8 and see what that looks like. And because these are randomly generated, every time I run this, it's going to look slightly different here. But this is the difference. UTF-16, see, it's this, and UTF-8 starts freaking out and it can't figure out how to actually display it on the screen, so it starts doing the byte representations there. And meanwhile, ASCII just sits in the background going, what are you guys talking about? I don't understand. And if we, of course, go out to the hard drive and let's look at this file we just generated, voila, assuming your application you're viewing this in can handle it, it's going to view it correctly. Otherwise, it may just crash. It may show random data. Buyer beware, not all Notepad applications are the same. Let's take a look at base64 encoding. This is often very misunderstood as to why we even need it. So base64 encoding is used when we want to transmit special characters. Now, what do we mean by special characters? Remember, hardware back in the day, especially like old dial-up modems, and believe it or not, those are still used like in some credit card machines and things like that. Well, guess what? Sometimes they would have what's called a command sequence, and special characters, anything outside that ASCII range, could really give you a bad day. It could shut the hardware down, it could reset the speed, it could do some other crazy things. And there's all sorts of other craziness too. So for example, when you send an email and you have an attachment, typically that attachment is base64 encoded, because guess what? The email protocol also uses special characters and special sequences. And if you just happen to have that in there, it could completely mess up your email. So base64 is kind of a universal way of saying this is how we're going to encode information to avoid special characters and avoid really weird scenarios that I've run into. So base64 is a group of similar binary to text encoding schemes, and blah, blah, blah. I could keep talking, but really what it does is it takes complex data and makes it less complex, and you can switch it back and forth. So we have this make data, hello, hard return, line feed. Not super fancy, but we can encode this. And I wanted to just keep this part very simple, but you could make this data as complex as you wanted it. So let's go ahead and take our data, and we're going to just play around with this. I'm going to say q byte array bytes, and then let's just give it our data. Now, what did we just do? We took a Q string, which is Unicode, and put it in here. Uh-oh, that's not good. Notice how this is saying, uh-oh, no matching constructor for initialization, because automatically Q byte array is saying, I don't know what you want me to do with this. This is Unicode. So we need to actually convert this. Let's just say to, and we could do to Latin 1, to UTF-8, to UTF-16, doesn't matter. I'm just going to do UTF-8. But remember, from previous videos, UTF-8 can have a massive range of characters. This is where base64 comes in. So what we want to do now, get rid of that little yellow thing. I'm going to say Q byte array. Let's call this encoded. And we're going to say bytes dot to base64. And then we have some options if we wanted to. I'm just going to use the default. It's really that simple. I know I say in this course a lot, it's really that simple, but it just amazes me how easy this technology is to work with. So we're going to go ahead and decode that. So I'm going to say, and I'm just going to show you the static way of doing it. Q byte array from base64, and we're going to take the encoded and just go ahead and decode that back. It's really ridiculously simple. And honestly, you're going to run into base64 quite a bit out in the real world, believe it or not. Once you start working with protocols, especially hardware at some level, when I say hardware, we're not talking building your own Linux distro or something like that. I mean, if you're going to work with like a modem or something, you're going to run into these weird instances where the data you're sending is going to like reset the modem or something like that. Let's go ahead and save and run. Let's see what encoded and decoded look like here. Ta-da! So encoded, this is what base64 looks like, and decoded, this is what it looks like. So really what we're doing is we're making sure this data is safe to send. Now, in some cases, you may not even need base 64, but I guarantee you throughout your career, you're going to bump into it. Let's talk about hex encoding. So hexadecimal numeral system is a positional numeral system that represents numbers in a radiance of 16. This is something I absolutely love doing to junior developers, and maybe it's a bit evil of me, but I'll say to them, well, can you send it to me hex encoded? And then watch just fear cross their face because they don't really understand hex encoding. And then you see them sneaking off to look it up on Google. So all hex encoding is, it's just kind of a standardized way of viewing things, and it does it through a radix of 16. It's really simple. So I'm actually just taking the same code from the last video where we talked about base 64 encoding, and we're just going to pick up right from there. So all we're doing is we are using a QString, which is Unicode, and we're generating some data. In this case, 0 to 9, hello world's hard return line feed, and we're putting that into a Q-byte array using UTF-8. Now, for the fun part. Q-byte array to the rescue. I'm going to say encoded. And we're going to say bytes dot to, and you notice the API here. Whenever you're in Q-byte array and you want to convert to, you just type the word to, and you get all of these options. There it is right there, 2 hex. And it even has a char separator of /0. That's pretty standard. And then, of course, let's go ahead and decode it. So we're going to say Q-byte array, decoded. And yes, I admit it's a little bit mean of me, but I do that to junior developers. I'll say, hey, send that to me hex encoded, and just watch them freak out for a minute. Say from hex. And let's go ahead and take that encoded data and just decode it. Again, very, very simple. Once we do that, we're going to grab this guy, bang, paste him in. Save run. So here is our encoded representation of the data. Here is our decoded representation of the data. Hex is fairly standard. If you've never heard of it, go out and research what a hex editor is. And this is how you would view, say, raw binaries and modify them if you felt like it. Hex is a universal standard, and almost everyone should have some basic grasp how to encode to and from hex. Let's talk about compression. Now, this is an often misunderstood topic, and not a lot of people cover it in classes because it's complex. What are we talking about? Well, we're going to take a chunk of data, let's say for an example, 100 megabytes, and we would compress it or shrink it down. There's tons of reasons why you'd want to do this. For example, let's say you wanted to email a file to your colleagues. You don't want to send 100 megs, you'd want to send something much, much smaller. Or let's say you were going to transmit this information and you're paying on a per meg basis. You don't want to pay for 100 when you could only pay for 25. Point being, once you've done whatever you want to do, you want to take it back to its original state and decompress it. You see how the original is 100 megs and the decompressed is 100 megs, while the compressed is much, much smaller. That's literally what we're talking about, is taking something, compressing it, and then decompressing it. One of the major hurdles with compression is just simply getting it to work. And there's also some things that come to mind. For example, when I said we're going to work with compression, somebody probably got excited and said, oh, we're going to work with zip files or 7-zip. Not necessarily. You see, these are compression algorithms, and in their own right, they're conglomerate of other libraries. And they're not backwards compatible. Usually. I have to say usually because, yes, there are times where they are. But for example, if you're going to compress with zip, you need to decompress with zip. You compress with 7-zip, you're going to need to decompress with 7-zip. GZ, same thing, but they do mix and match them. So you will find zip that uses GZ under the hood and things like that, and it gets crazy. I've seen all sorts of things, but usually it's a 1-for-1. Compress with one, decompress with it. Don't try to mix and match them. To make it even more challenging, somebody out there is going to ask, well, how do I make a zip file in Qt? You don't. That functionality is not baked into Qt. So how do you get over that limitation? Well, remember, Qt is built on C++. And if you simply go to Google and type C++ zip, you're going to find a whole ton of things. But you're going to basically fall into 1 of 3 categories. You're going to find a already built library like zlib, which is huge, and it's actually very awesome. I've worked with it before, but it has its own headaches, it has its own documentation, and you really have to dive into their way of doing things. On top of that, documentation can be a bit spotty on some of these projects. If you want the raw source code, of course, there's tons of it out there. For example, here is a 7-zip C++ implementation, or I should say a wrapper around it. And this is actually fairly decent, but again, you get the full source code, so you got to fix anything that's not working, or contact the author and hope that they do it. Point being, it's not the most desirable situation for somebody who just wants to build a zip file. So without further ado, I would like to say there are people out there doing things such as QUA or QuaZip. This is a wrapper between Qt and C++ libraries that allows you to seamlessly build archives. For example, zip archive. So if you're asking how do I build a zip file, 99% of the time I'm going to say go Google QuaZip, read its documentation, and figure out how to make it work. Unfortunately, because these are third party and they're outside of Qt, I'm not going to include them in this course, simply because it would be a nightmare keeping up with any changes they make on top of the changes that Qt makes. That being said, there is some compression functionality baked into Qt in the form of GZ. Let's go ahead and take a look. We're going to take a look at some very simple compression. Now, I have to stress this is simple. We're not making a zip file or a 7-zip file or anything like that. Again, to do that, you're going to need a third-party library. It's just simply not built into Qt. Now, what do we want to do? We want to reduce the size of some data. We're going to use QCompress and QUncompress. Kind of scroll down, you see I have a display function here. We're just going to display a title, data length, and the actual data. And then we've got some data with some very long and annoying data in there. It's just going to keep going and going and going, scrolling as fast as I can all the way to the end. Very simple, just lots of data. We're going to compress it and decompress it and then view it. So let's go ahead and compress it. And as you might have guessed, we're going to simply say QCompress. And it wants the qbyte array and a compression level. So let's go ahead and highlight, hit F1. You'll see the compression levels between 0 and 9, 9 being the greatest. You may automatically go, well, I'm just going to do a 9. Not so fast. So the higher the compression, the more CPU, power, RAM this is going to take, and more time it's going to take to compress this. So if you're time sensitive, a 9 may not be beneficial. If you're on a low power device, guess what? 9's going to start chewing that battery. Might be something in between. For our example, because I'm on a big beefy desktop, I am going to do a 9 just to show you what it looks like. So I'm going to say, take that data and then hand it a compression level. You don't need it. It's automatically -1 by default, or the absolute lowest compression level. Now we're going to go ahead and take this compressed data. We're going to decompress it. Again, super simple. QUncompress does not need a compression level because it figures it out on the fly. And it's just that simple. Unfortunately, it's overly simple. Like I said, if you want to build some sort of compressed file, this is not the way. You're going to need a third-party library. Go ahead, save and build. And here we go. So the original is 920. Our compressed is 57. Look at that. I mean, that's a huge compression ratio, mainly because we've just repeated the data over and over again. But then decompressed is 920, which matches the original. So why would you want to do something like this? Well, let's say you have to send across a network, but it's a slow network and it costs like on a per byte level. You'd want to definitely compress that data. So I'd rather pay for 57 than 920. Or if you have very limited storage, you may want to compress this down before storing it, that kind of thing. Let's go ahead and make our own custom file compression. Why? Why not? Because I get asked this over and over again that, hey, I know it's not built into Qt, but how do I actually do it anyways? Because I don't want to deal with a third-party library and I don't care about backwards compatibility with zip files. Well, we're going to use a lot of custom code. What we're going to do is make a file, compress a file, and then decompress it. Again, this is not compatible with like zip files or anything like that. We are building our own compression format, and we simply don't care what anybody else in the world's doing. Not necessarily the best idea, but let's go ahead and make it happen. First things first, we're going to make a file that we're going to compress. I don't want to play around with anything else on the file system because I don't want to take a chance of corrupting one of my files. Now, we're going to do this just to show, hey, we can actually make some random data. I'm not going to spend a lot of time on this function. It's things you've seen before. So I'm going to say bool, make file. Let's go with QString file. Actually, let's call this path. Why not? I'm a little excited to make this video. This is kind of the fun bit when you can actually do something. So we're going to say qfile, file, go ahead and give it the path. And then we, of course, want to if file.open. We want to make sure we can open this bad boy in the write mode. So we want QIO device. We want write only. Now, if we are unable to open this in write only, we're just going to simply return false here. I'm going to assume this works. I'm going to scroll down, get some screen real estate here. Now, once we're at this point, I'm going to say q byte array data. And then I want for int I equals, this is why, because I just want to show you, hey, we're going to get a high level of compression because we're using pretty much the same data over and over again. This is a perfect scenario for something like this. Like if you had some sort of bitmap you wanted to compress, this would be great. Now, I'm going to say data.append, and we want the QString number. So we're going to make a QString out of an integer there. And we want this to be UTF-8. And let's go ahead and say plus r/n. So we got a character return line feed, so we're compatible with Windows. You Windows people, I'll tell you. Actually, I like Windows. I play a lot of video games on there. Subnautica is one of my favorites, and Subnautica Below Zero just came out at the time of this recording, which will probably date this video. Both really great games. And then we are going to close. Now remember, close will call flush for us, so we don't really need to worry about that too much. Now, before we move on to the next step, I am going to put in a little function, and I'm just going to copy and paste and explain it. Get header. What we're going to do is make a header here out of a qbyte array, which is just this. And feel free to use whatever you want, but it should be unique. This is going to signify the end of a chunk when we compress and decompress. This is kind of how some file formats are like this, where they will write a chunk of data and then put a special marker and then write another chunk and put a special marker. And you need that to really differentiate those chunks. Let's go ahead and compress a file now. Or I should say, write the code to compress the file. So we're going to say we want the QString original file name and the string new file. So we don't want to overwrite the existing just because I'm that paranoid. Now we're going to say qfile. I could actually spell qfile. Let's call this O file, short for original file. And of course, give it the original file name. And let's say qfile. And let's call this N file, short, of course, for the new file name. This is where that special header is going to come in, right here. And I actually need to move this up now because we're going to use it. In case you've been skipping around, we're going to use this header to kind of define where the chunks begin and end, because we're going to write this in chunks. We're going to say q byte array. Header equals, of course, get header, which just gets that special code or that magic number, so to speak. You'll see that kind of repeated throughout different code libraries where they have like a special marker. Then I'm going to copy and paste just a smidge. We're going to say if we cannot open the original or if we cannot open the new, then we want to return false on this, and we want a chunk size. I'm saying 1024. It's much more efficient to do a larger number like 15K or something like that. Most modern hardware thinks in terms of bigger numbers. If you're a real hardware geek, you could look up the actual chunk size of, say, your hard drive and things like that and figure that out. All right, now I'm going to simply say while, and I'm going to say not the original file dot at end, meaning we're just going to keep looping until we hit the end of that file. We want to go ahead and read it. So we're going to say q byte array buffer. And we're going to go ahead and read. And we're going to read using, of course, that size we defined. In this case, 1024. But you can definitely tweak that to however you need it. Now that we've read that chunk of data, we're going to go ahead and compress it. So I'm going to say q byte array compressed equal q compress. And then we're going to go ahead and compress that buffer. Again, you can enter a compression level. I'm going to just to show how it's done. Very simple. Once we have that, we're going to go ahead and write that header. So I'm going to say nfile dot write. We're going to write that header in there. That way we know, hey, this is the beginning of a chunk. Now, what I want to do is actually say nfile dot write. And we're going to write that compressed data out there, all in one chunk. Very simple, very easy to use, and then we're going to just simply close our files. And then return. And if we wanted to, we could say something like finish compressing. That way the user gets some sort of feedback, and you can make this little bit here a little bit more professional and give them a reason why we couldn't open the file and that sort of thing. Now let's go ahead and decompress that file. So I'm going to go down here, and we're just going to make another function called decompress file. It's going to, of course, have the original file name and the new file name. I am going to copy and paste just a little bit of this just so we can speed this up just a bit because it's virtually the same thing in reverse. We're going to say qfile, ofile, qfile, nfile, which stores for short for original and new. We want to get that header, which of course is that special marker we're going to use, and we want to use a chunk size. Then what we're going to do is we're going to make sure we can actually open those bad boys up. From here, of course, I want to close things down appropriately. Now comes the absolute fun part. We're going to go ahead and read this bad boy back and figure it out. If you followed along, what we're doing is we're writing a header. And let's actually scroll up here. So we're going to write the header, then write the compressed data. No, we have no idea what size this compressed data is going to be, which is why we have the header. So we're going to simply read the file till we hit a header, read the compressed data until we hit another header, and so on and so on. Sounds kind of hard if you're a newbie. If you're an old person like me, it's very simple. So I'm going to say q byte array, and we're going to call this buffer. First thing we're going to do is we're going to make sure we created this file. We want to make sure we're not trying to like read a zip file or something like that that we just have no idea how to work with. So again, you'd have to use a third-party library if you really wanted to do that. So I'm going to say peak. We're going to go ahead and peak that size. You may be inclined to go, no, wait a minute. What is peak? Highlight it, hit F1, reads these bytes without side effects, i.e. if you call read after peak, you will get the same data, meaning this does not move that file cursor head. It just kind of like, you know, you ever peek open a door? That's what it does. It gives you the data without moving that cursor. That being said, now that we have this, we can say if not buffer, and we want to say starts with our header, then it becomes very simple what we need to do. We're just going to tell the user, hey, we did not create this. Let's go ahead and close both those files and then hit the eject button on our application here and just go, nope. I shouldn't say the whole app, just this function. All right, now what we want to do is we want to, now that we know this is something we created, we're going to say, go ahead and move forward. So I'm going to say file.seek, and we're going to seek the header length. Not left. Work with me, keyboard. Length. I don't know why that did that in double parentheses, but that's kind of freaking me out a little bit. So that is going to actually move the cursor forward. We could have very easily just said read, but I want to go to the very end of the header and not have to backtrack later. That being said, what we're going to do now is we're going to read this file back in chunks. I'm going to say while, not ofile dot add end. Kind of bugs me the IDE does that, where it doesn't like my coding style and it wants me to use theirs, but I think you can tweak that in the settings. I just haven't done that on this virtual machine. And we're going to go ahead and peek this thing. And we're going to grab that whole size 1024. Again, you can adjust the size however you want. And then we're going to say q int 64 because this could be a larger file. Call this index equals, and we want to get the buffer dot index of. We're going to get the index of the header. Now, notice what we're doing here. We are reading in a buffer or a qbyte array of 1024 bytes. That's going to chew up memory. So if you're going to increase this, just be very conscious of the fact that you're going to use more and more memory. Now, because we're doing this all on the stack, that memory should be released almost immediately back to the OS, but we want to make sure we're super careful about it, especially on devices with low amounts of RAM. It's not so much a consideration nowadays, but back in the day, that used to be a major headache. All right, now I'm just going to pump something out just for me. I should actually make this a Qdebug. If you watched our section on logging, we could actually turn that off so we don't see the debug message. From here, what I want to do is say if the index, if I'm going to screw something up in this video, it's going to be this little spot here. So we're going to say if the index is greater than -1, we found a header. Else, not have a header. So really, we're just taking two actions here. And if you're like me, you're a stickler for the way these brackets look, you can definitely break this out into lines like this. But very simple, we just want one or the other. We have a header or we don't have a header. So if we don't have a header, what I want to do is say qinfo read all, no header. That way we know, hey, something's going on. And we're just going to read this whole thing off into one buffer. So I'm going to say buffer equal ofile read all. So we're just going to read that whole thing in, meaning this file is smaller than what we expect, and there's not another chunk. There's only one chunk in this file. Now from here, we have a header. And let's say qint64. Let's call this max bytes equals index. So we want to know how many bytes to actually read in, which is, of course, right here. So we're going to say max bytes is that guy. And from here, we're going to say qinfo reading max. Actually, I don't want to say max there. So what we're doing here is we've found a header. We're going to read in a chunk. So I'm going to say buffer equal ofile.read, and we're going to read in a maximum number of bytes. Then what I'm going to do is say ofile.read We could do a read, we could do a seek, doesn't really matter, but I'm just going to do the header dot length. Meaning, because we found that header, we're going to read up until the header and then put that into a buffer, and then we're just going to move ahead the rest of the header, and then this whole process starts over again. So basically, from a high-level view, we're jumping from header to header is really all we're doing here. Now, as long as our compression is working, our decompress should work just fine. So right here, we're going to say q byte array decompressed equals q uncompress. And we're going to give it our buffer. And then I want to say end file for new file. Write, we're going to go ahead and write the decompressed data there. And then end file, I am going to actually flush this just to make sure that thing is just jumping and pumping and everything's working great. Now at this point, I'm going to give it a build just to make sure I haven't screwed up any code, because like I said, if I'm going to screw anything up, it's going to be that section. Without further ado, let's make this thing work. Quick recap, make the file. We're going to use headers. We're going to compress it using writing the header, writing a chunk, writing a header, writing a chunk. Decompress is the opposite. We're going to read a header, read a chunk, read a header, read a chunk. We're going to do that till we get to the end of the file. I am going to copy and paste some rudimentary code in here. We've got some Q strings, original file, compress file, decompress file. So we're going to make our file, original file. We're going to compress the original file to the compressed file. And then we're going to decompress from the compressed to the decompressed. So we're going to have 3 files here, original, compressed, and decompressed. Fingers crossed, moment of truth. Let's give this a good run here. All right, the original was created. We finished compressing, and then we jump from header to header. So header found, header found, header found, and we just keep going, going, going until there are no more headers to be found, which means we have read that entire file and decompressed all the chunks, and we're good to go. Let's go out to the disk and see what's going on here. So I'm going to go here. Here's our project. All right, here's our original. Let's just crack this open. Again, very simple file, not a lot of data to it. There's just, a bunch of numbers. If we look at this, the properties on this is 4.9 kilobytes. Our compressed is not human readable. This is compressed. And you see there is our header right there, our little marker. And if you search this file, you'll see this repeated over and over again between each chunk. This thing is 1.7, much, much smaller. And then our decompressed is the same size as the original and, of course, has the same content. Again, at the risk of being repetitive, this is our own proprietary compression format. This is not backwards compatible with, say, zip or 7-zip or anything like that. If you want to use those formats, you're going to have to Google, and you're going to have to search for a library that handles that. This section focuses on what's called serialization, and if this is a new concept for you, prepare to have your mind completely blown. For example, we could take a class, in this case a cat, that has some properties, name, color, and is it hungry? Cats are always hungry, so we know that's going to be true. But we can take this instance of this class and serialize it to a file. That means you actually take the class and all of its values and put them in a file and put it into storage. From there, guess what? You could shut the computer off, pull the cable, let it sit in a closet for 6 months, and then turn it back on. And then from storage, you would deserialize that back into an instance of that cat class with all of its properties restored. This is extremely cool. Let's take a look at serializing and deserializing simple data. And we've done this before in a previous chapter under the file system. We're going to use QDataStream and QFile. Remember, we've done this before. This is just a quick review. So QDataStream, QFile, really all we're going to do is we're going to open a file and use QDataStream to save data encoded into that file. Because of that, we have a couple functions. We have save file, read file, and then I've got some code down in main which simply calls all of that. So we're going to make a file called test, we're going to save it, and then we're going to load it. All right, in our save file, we're going to open this in write mode, otherwise we're going to turn false. This is where we're going to actually start coding here. What we need to do is say QDataStream, and let's call this out, and let's give this our file. This is assuming, of course, that we have opened that file in write mode, and we're good to go. From here, I'm going to say out.setVersion. This is critical because different versions of Qt do this subtly different ways. They've improved it over time. They're not compatible with each other. Let's put it that way. I should say most of the time, they're not compatible with each other. So we're going to say Qt, and then you have every version available. So if you had previously worked with a different version, you could definitely downgrade. But if I'm starting fresh, I always start with the latest version. And then I want to say, we're going to make a Q string. Let's call this title. And the answer is 42. If you ever read the book, Hitchhiker's Guide to the Galaxy, you know exactly what I'm talking about. And then I'm going to say QInt, and instead of just doing a normal int, I'm going to do a QInt 64 just to show you can do different types of data. And of course, that number would be 42. From there, I'm going to say out title and out our number. Then we simply close the file, which we'll call flush underneath. But notice the ordering is very specific. We're doing title, then number. That's important to remember that the sequence has to match up when you go ahead and try to read it. Now, when we're in read land here, this is a little bit different. What we need to do is say QDataStream, call this in, and give it our file. Now we need to check the version. This really helps us ensure that we're working with the version we expect. And then from here, you could do, a simple switch statement to depend on what version you want. Highly recommend you use the newer versions because they're much, much better. But if we cannot do this, then we're going to just simply say QCritical, hey, the versions don't match. Or you would simply load it in the specific version and then save it back. You know what I'm talking about. I'm going to say file, close. And we're going to turn false, just saying we couldn't do it. But once we've gotten this far, it's very simple. We are just going to read that back. So I'm going to say QString, title, and QInt64, num. And we have to do this in the same order. If we try to reverse it, we're just going to have a bad time. We're going to get corrupt data. It's not going to work. And it could actually potentially crash your program. So you got to be a little bit careful here. I've only seen it crash one program in the history of my entire programming career, but it was bad. So just don't do it. All right. Then from here, of course, because we open a file, we should go File, Close, and we're good to go. Let's go ahead and save run and see what this does. So sure enough, we're going to run, saved, the answer is 42 and 42. We read that back from the file. We can, if we wanted to, go out to the file system. Let's go into our little folder here. Here's our text file. And ta-da, this is what it looks like on the actual hard drive. So this means we can actually send this across the network or save it on a USB thumb drive and then read it back just like we're working here locally. This is absolutely awesome that you can take data and serialize it down and then do something else with it. All right, get ready. We are going to serialize a class. Specifically, we want a class that can save and load. How? We're going to use operators. You may have zoned out that day of C++ class, so pay attention. What we're going to do is we're going to take this test class, and I've got some code filled in here. All this thing really does is it just has some very basic functions. We fill, we have a name, we can set name, and we can get a map. We have a variable called name and a variable called map. This is very, very simplistic code. All we're doing is building a QMap and just saying, hey, we've got some existing class out there and we want to make this easy to work with QDataStream. So we also have a couple functions, save file, which we're going to take a pointer to. Remember, you cannot make a copy of a Q object, so we're going to take a pointer to our class, and we're going to write this out to the hard drive. We've already got the disk code up, and we've got a data stream ready to go with our version in there. Remember, it's very important that you make sure your version numbers line up between saving and loading. You want to make sure that internally Qt is using the same methodology. All right, before we dive in, last thing we're doing is we're saying make an instance of our class. We're going to fill it with some random data, and then we're going to save it and then load it back. So first things first, let's jump into our class. What's missing here? How do we really work with this thing? Well, we want to be able to use operators. And I'm going to go right in here. And we're going to say friend Q data stream. We're going to say operator. And we're going to use that operator right here. So we can just simply, you guessed it, push that right out to the data stream, and it does it all for us, almost like magic. We're going to say Q data stream. Stream, and in case you're wondering, this is not proprietary to Qt, this is just C++. There are probably better ways of doing this. Or say test and T. Now, better usually means more complex, so we're trying to keep it as simple as possible here. We're going to say Q info. We just want to know that we're calling this operator. That way we know it is successful. And then from here, we're going to say whatever stream we were given, we are going to say, take our T and put in the M name. Remember, it's very important that you do the same order. So if you were to do, say, the name, then the map, you have to read that back in the same order. So we want to make sure that this order is going to match, and that's why we're doing this in the class itself. We're going to say stream e.mmap. Now that we've got our order down, we're going to go ahead and simply return, you guessed it, that stream back to the caller. And then it's very simple. I'm just going to grab this code, and we're going to work with the other operator so we can read back from that stream. And this one does not take a const, so I have to get rid of that so it will work correctly. So we're going to say QDataStream, and then we want our test. And then let's go ahead and tell the world we're using that. And then we just simply flip these around. Remember, they've got to be in the same order, so we want name to name, and then map to map. It's really that simple. A lot of people get mystified by this. They make their own functions like to file, from file. I'm guilty of that as well, simply because a lot of people haven't really wrapped their head around operators. Go ahead and save and rebuild just to verify we didn't goof anything up. Once we got a good build, we can safely move on here. Flip back over to our main, and we've got all of the, I call it plumbing code in place. We've got an instance of our class, we're filling it, then we're going to save load. So let's just jump right into save here. We've got the file open, we've got a data stream. From here, what we want to do is actually work with this thing. So I'm going to say, let's go ahead and say data stream And we're just going to take our pointer and shove it right through, and that'll call our operator. It really is that simple. You don't want to mess around with doing individual properties one at a time. Like you don't want to say like t.map or anything like that. You want the operator that we just built to handle all of that complexity for you. So you're just going to say, hey, C++, go figure it out. Now in here, in our load, things are slightly more advanced, but not really, because remember, when we're loading, we're actually creating an instance. So I say test T, and we want to load this into the new instance. So I'm going to say data stream, go ahead and load that in there. Now in a, 10 updates available. I should probably update this virtual machine. In a real world application, you would actually do something with this now that you've deserialized it. So let's go ahead and qinfo this back. And we're going to say name. And let's just read that name property. And let's say t.name. And in case you're wondering, yes, we could have used a QString view. I just simply didn't feel like it. Very simple to fix that problem though. Say for each. That whole 10 updates thing got me totally distracted. I did actually update this virtual machine the other day, and now I got 10 new updates. Darn you, updates. I'm horribly distracted. So we're going to say, let's go ahead and get the map, and we want the keys. Very, very simple the way this is going to work. And we're just going to say qinfo key. And let's just denote our key value pair just to show that we can do this. In case you're wondering what I'm doing, it's just absolutely nothing, to be brutally honest with you. I'm just showing you that we can work with this because it's going to load it from the disk into our instance, and then we can work with it directly. Very simple code. Now, in the real world, you'd probably actually, instead of working with it in here, you would actually return a pointer. Very simple to do that as well. Let's go ahead, save, and run. Let's see this thing in action. All right, so we have serialized, we've deserialized, here's our test object, and here's all the information we deserialized from the disk. This is actually really cool, and it's really easy to work with once you understand how it works. The major takeaway here is do not fight C++. Instead, use operators. They're very easy once you wrap your head around them, and they save you a lot of headache later on. Let's take a look at how to serialize to JSON. If you don't know what JSON is, it is, well, just a human readable format, and it's become an industry standard. To do that, we're going to use the QJSON document. Now, the last video, we actually went into our class and we used an operator. We're going to deviate from that. Instead, what we're going to do is use a class called converter. And this is just a blank class. I'm going to build this out in this video. The reason why we're doing this in a class is because as standards come and go, I don't want to continually modify this object. Instead, I just simply want to use a converter. Now, this is going to be a specialized converter for this class. In a production environment, you would actually use templates. Let's go ahead and take a look. First thing I want to do, though, is I want to go into our test class here, and I want to be able to set map. You notice how we only have a getter here. So I'm going to right-click on this, Fractor, and generate a setter. There are some problems right up front. For example, this is going to say const. So let's get rid of that, get rid of that. And then let's flip back in here. And do a little bit of surgery on this class, just to get it the way I want it. Again, with programming, there really is no right or wrong answer. Yes, you can use what the IDE recommended, or you can do it your own way like I did. Make sure those errors clear up, and we're good to go. Let's give it a good build just to make sure we don't have any little gremlins. All right, now our converter class is going to take a whole lot of includes. So I'm just going to grab those off the screen. Let's copy paste. Might not even use all these. I was just taking a wild guess what I'm going to do. QObject, QDebug, QFile, QDir, QVariant, QVariant map, QJSON object, QJSON array, QJSON document, and QMap. That's a lot of includes. So let's just go through these real quick. Definitely going to be using a file. I don't know if I want QDir in there or not. I'm just going to leave it in there for now. QVariant is a wrapper around an unknown object type. And then QVariant map is a map. Think of it like QMap, but for QVariants. So you have key value pairs to variants. You have a QJSON object. Think of this almost like QObject. It is the base class for all JSON objects. And then you have QJSON array, which is, of course, an array of JSON objects. All of that forms the QJSON document. And then we have our trusty QMap, which is just key value pairs. We've seen that before. Now, there are a billion different ways of doing this. This is just simply a design choice I'm making. Feel free to change it however you want. I'm going to make this static. And I want write JSON. And then from here, you could use templates or whatever you wanted to do. I'm just going to hard code in our class here. And then I want to put in how to read that back. So we're going to have a write JSON and a read JSON. Very simple, very easy, and as standards come and go, we could simply say, write whatever standard, read whatever standard, so on and so forth. Or you could, instead of saying write or read, you could say to and from. Doesn't really matter how you do it. All right, now that we've got those in there, it just simply becomes a fill in the blank kind of scenario. So what we're going to do is we're going to give this our name and then our map. And if we look at our test object here, we have a name and a map. So we want our JSON object to kind of mimic that. So in here, I'm going to say QVariant map. I might copy that because I'm going to use it over and over. So we have map and items. Now let's say map items equal. Yeah, I screwed that up. That wouldn't make much sense, would it? Let's say name instead of items. There we go. That would make a bit more sense. So we're saying our map name is going to be the object name, which is just a Q string. Now let's go ahead. I got a little ahead of myself here. We're going to do a for each. Let's do a Q string out of every key. We're just going to build out this little map here. I'm going to say items dot insert. And let's go ahead and add in our key. And now we want a Q variant. And we want the object map dot value of whatever the key is. So really all we're doing is building a QVariant map using the map that we already have. Now we can get to the point where I was a little hung up. We can say map items, there we go. So really all we're doing is we're taking that map, that QVariant map, and we're shoving it into a QVariant and putting it into our map items. So we have map name and map items, very similar to our test class, where we have name and then a map. The only difference is instead of calling it map, we're calling it items. It's really not a big deal. Now that we've got that, we can actually build out our document. So I'm going to say Q, JSON document. And we want to say from variant. And what this is going to take a Q variant and actually convert it into our document. And we're going to take our entire map, put it right in there. Now, does the naming really matter? No, absolutely not. We could have named this Fuzzy Button Kitten, whatever we wanted to call it. Now, it's just very, very simple. We are just going to, you guessed it, create a Q file. And I'm going to copy and paste some stuff just to save a smidge of time. So we're going to say Q file on our path. We're going to open that in write only. Otherwise, we're going to say couldn't open the file, the reason why, and return out of here. Assuming we got into this point, we're going to go ahead and close that file. And right before we close it, we are going to write that out. And we're going to say our document to JSON. And you notice what to JSON is going to do. It's going to return a Q byte array, which works perfectly with our Q file. It's really that simple. Again, adjust this as you need, but keep it simple. And when you're building out your document, you want to try and mimic the class that you're actually serializing. Now that we've written our JSON file, let's go ahead and read it back. So I'm going to clap some of this, just get some screen real estate back. And I'm going to, through the magic of copy and paste, ta-da, Q file. We're going to open that in read only. Otherwise, we're going to say, something bad happened. And we're going to return a null pointer if we couldn't read. From there, of course, it becomes very simple. I'm going to say Q byte array, data equal file read all. We're just going to read this whole thing all in one chunk. And then because we're done with our file, we want to go ahead and close it. We don't want that file open any longer than we need it to be. Now we need to convert that Q byte array into a JSON document. So I'm going to say Q JSON document. And it's simply from JSON, which is going to take a byte array and convert it into that document. Now I want to go ahead and let's make an instance of this class. This is the part of the video that's probably going to make some people twitch. You notice what we're doing here. We are creating something out on the heap, and we're not using any memory management whatsoever. So this could potentially cause some issues. Again, refer back to the section where I talked about memory management. You could, because this is a Q object, if you wanted to, make it the parent. But I don't know what the caller is going to be doing with this, so I don't want to take ownership of it. I'm just going to hand them a raw pointer. And let's go ahead and set the name. We're going to grab the document. And then it becomes just like working with an array here. Let's say name. Because this is a Q variant, we have to convert it. Say toString. Now we have a fundamental problem. If you refer back to what we wrote up here, we're taking an entire map and converting it into a Q variant. So we have to have some way of getting that back into a Q variant map. So I'm going to say Q variant map. Let's call this VMap. And we're going to use something that a lot of people don't even know exists. It is called Q variant cast. And it does exactly what it says it does. It takes something from a Q variant and casts it into something else. And instead of working with a Q object or a Q map, we're going to say Q variant map. And we're going to grab that document. Remember, we put that in items. So it's going to take that Q variant, convert it into a Q variant map or the key value pairs for us. So we don't have to go through and recursively read that document over and over again. Then we'll say Q map. And let's put this in the actual data types that we're going to work with. And we want the QString key in the VMap keys. Don't really need to do this little bit, but I just kind of wanted really the convenience of doing this. Instead of pumping it all out, I'm going to just set the map directly instead of getting the map and adding them one at a time. So let's go ahead and say, insert this. Grab that key. All right, now that we've built our map, instead of grabbing it from our test class and inserting them one at a time, I'm just going to set that entire map. And voila. From here, simply going to return our pointer. Again, there's a billion different ways you could have done this, but the major takeaway is you can simply read that document. Unlike QDataStream, it doesn't have to be in a specific order. I could have switched these around because really what you're doing is you're working with that object and then reading from the document. Okay, assuming we don't have any mistypes or little gremlins, let's go ahead and give this a build. Everything should work fine, but let's build it just to be sure. We got a good clean build. Let's go over to our main. And we've got two functions ready to go. Write JSON, read JSON. Pretty self-explanatory about what they're going to be doing. I've already included our test in our converter. So let's go ahead and say test T. We're going to call our fill function, which just fills in that information. And then we're going to say converter. Actually, let's do it this way. Converter. There we go. My coffee cup got in the way. That was a little disheartening. Almost knocked my coffee off. That would have been a bad day right there. All right, so what we're going to do is we are going to create an instance of this test class, fill it with some data, and then we're going to say converter, write JSON. We're just going to take our test and put it into that path. And read JSON is, of course, the exact opposite of that, where I'm going to say test. And we're going to say T, converter. Go ahead and read that JSON back. Let the converter do all the work for us. And this is where we have to do a little bit of cautionary programming. So let's just say if there is no T, then we want to let the world know, hey, we could not load that object. Now from there, we could take this just a step further and actually work with the object that we just deserialized. Now, note, this isn't really true serialization and deserialization, as somebody in the comments will probably point out. Really what we're doing is we're just making an instance of a class and then persisting those properties back to the disk and then loading them back. But this is actually very much industry standard. Now, you may be asking as I'm typing, what would you really use this for? What's the main reason for this? Well, it's data interchange. Let's say, for example, you have a program and your friend has a program and you want to exchange information between the programs. Essentially, their program is going to make their own version of this test class. It could be in a different language altogether, like Python, Java, .NET, doesn't matter. You're going to send them that JSON file and they're going to load it up into their own object. That's exactly what JSON's for. It's actually pretty much used in mobile programming and things of that nature, where you're sending data between, say, a mobile device and a server, and you just need to make sure it gets there in one piece and that it's easy to work with, hence it's human readable. And let's go ahead and read that key back. All right. If we've gotten to this point, we have a test class, we have a converter, and we have our helper functions that are just going to test this out. Our main function is simply going to call write and call read. Let's give this a build, make sure everything works. All right, let's go ahead and run it. Ta-da! Test object and then our keys. This is actually really, really cool. Now, I did mention that JSON is human readable. So let's dive out to the hard disk and see what that looks like here. I'm going to go here. And there's our file. Crack this open, and this is what JSON looks like. This is human readable. Notice something right off the bat. We put name in there first, but it's actually at the bottom of the document. Don't try to fight the QJSON document class. Just let it do its thing and let it put things where it thinks they need to be. But you can see we have our items, and there is our map, and then we have our name right here. Everything worked as expected. Let's take a trip down memory lane. We're going to look at how to serialize to XML. Now, some criticisms of this is that it's retro. It's early 2000. Nobody uses XML anymore. Wrong. XML is used all over the place. I think it's actually even more popular than JSON just because it's older. It's still widely used. People still love it and use it. JSON is kind of creeping ahead in use because it's easier to read, but you need to know how to work with XML. So we're going to use QXML Stream Writer and QXML Stream Reader. We are going to reuse the code from the last few videos. So you can see here's our write JSON, and I'm going to hide that, and our read JSON. I'm going to hide that, and I'm going to comment these out because we're not going to be working with JSON in this video. This is just our simple little test app. We have our test file, which simply has a QString name and a QMap of QString. And then we've worked with some operators and things of that nature. Our converter class is really what we're going to be focused on. Notice how we have this write JSON, read JSON. We're going to add two functions to write and read XML. Now imagine this, it's a bright summer sunny day and your boss kicks in your office door and says, update the converter to use XML. Well, we're just going to go ahead and use the includes QXML Stream Reader, QXML Stream Writer. Man, it's complex to even say. This is one of the things that people hate about XML is that it's a little bit more complex. Let's go ahead and grab these and let's get this done before lunch because you know what? I like to eat. We're going to say, yes, boss, we'll get it done. We're going to go ahead and update that. So we now have a write XML and a read XML. Let's go ahead and right click and let's refactor, add definition. And right click refactor and add definition. Now you don't have to do that. You can actually type it in manually if you really want. I do it just to save a smidge of time. Now, because we're not working with JSON, I'm going to collapse down the constructor and all the JSON code, and we're going to focus strictly on XML. All right, let's start writing the XML file here. So I'm going to just copy and paste the code that we should know by heart now. Q file, opening the path with write only. We're going to say Q critical, couldn't write, and an error string if something bad happened. From here, we assume the file is open, and I'm going to go ahead and close it immediately, and then do my work in between. That way I'm not keeping that file open. Now, spoiler alert, you really don't even need this because as this goes out of scope, it should attempt to close it, but I don't always trust that. I always close my file. Now, let's go ahead and say Q XML stream, and you notice there's a whole lot of QMXML. So we want the stream writer. Call this stream. Go ahead and give it our file. Now, this is where a lot of confusion comes in here. So if you are used to working with the older versions of Qt, you're going to want to switch over to the stream writer and stream reader. The documentation is, of course, world-class, but it also has the added complexity that this is XML, and you have to follow all these elements and attributes. But at its core, you're going to start an element, end an element. In between those, you're going to have attributes and other elements. That is an overly simplified version of XML. This can get pretty complex here. If you've ever worked with Enterprise XML and you're very new, you know what I mean. So we're going to say stream set auto formatting equal true. We want the stream writer to handle it all for us. I don't want to have to worry about any formatting. Say stream, and we want to write a start element. Actually, we want to start document. Got a little ahead of myself here. Again, this can get a little complex. So we've got our start document. And of course, we can say write end document. You see what we're doing here. So now we have a document, and inside of that document, we can start working with things. So I'm going to say stream write, and we want a start element. And we need to give it a name. So I'm going to say test. And now inside that element, I want to be able to add attributes. So I'm going to say stream. And we want to write an attribute. Now, what is an attribute really? Think of it in terms of like this line here. This would be the element, and then these would be attributes. You can absolutely think of them almost as parameters. They are different under the hood, of course, but that's how we're going to think of them. And our attribute is going to be the object's name. Now you see what we're really getting at here. Now we can add different things like the name of the object. This becomes pretty simplistic. And then once you really understand the pattern, you can do a bit of copy and paste. So for example, right here, we're going to make another element inside of the element called items. Now you notice what we've done though is we've started, but we haven't ended. So absolutely we should end those elements. So I'm going to say here, and we want end element, and we can just do the magic copy and paste. Go ahead and end the element again. So if you're confused, think of it in terms of brackets here, right? So you have this bracket, which aligns with this bracket. So this would be an element. And then this bracket is in this bracket. So that's exactly what we're talking about, is almost a concept of scope. We start a document, we end a document, we start an element, we end an element, we start an element, we end the element. We just want to make sure we close that down as we go. That way you avoid any confusion going forward. We can almost collapse this down into a little block here. That way, it's very easy to understand what's going on. Now that we have this, it's just a matter of plugging in that map. So I'm going to say for each. And then let's go ahead and say stream. We're going to make an element in an element in an element. I think it's like Elementception. If you've ever seen that movie, Inception, really good movie. Now that we have that guy, let's go ahead and we are going to actually grab this. We're going to write some attributes out here. And let's go ahead and put the value in here. That is a getter, so I got to change that. Almost got a little messed up there. And then because we did our start element, we of course need to end that element. This is what I mean by XML seems a little bit more confusing and cumbersome than JSON, because now you have the complexity of you have to kind of control the flow of the document. You need to start a document, you need to end the document, you need an element. Elements can have elements inside of them. And every time you start an element, you need to go ahead and end the element. And elements, of course, can have attributes. This can get a little bit confusing. Now comes the fun bit. We get to read this back. Oh man, fasten your seatbelts. All right, so we're going to be in read XML. I'm going to just really grab some file code that we should know by heart by now. We're going to say Q file path in read only. Of course, we're going to generate something bad happened and return a null pointer if we couldn't open that up. Otherwise, we're going to say Q byte array data, and we're going to say file read all. So we're just going to read that all in. No longer need the file, so we're going to make sure it is closed. From here, we have this data and we need to do something with it. This is where Q XML stream reader comes in. And let's just simply call this stream and hand it our file. Notice it has a very similar API. but that's about where it ends right there. So what we're going to do now is make an instance of our test class. Again, this will give some people a twitch because we're making a pointer out on the heap and we're not taking ownership of it. Again, I don't know what the caller is going to do with this, so I don't want to take ownership of it. You can 100% put this in a smart pointer if you really felt like it. And let's go ahead and build out a map that we're just going to use with set map. So I'm going to say qmap. Again, there's a bunch of different ways you could have done this. I'm just showing you one simple way. Now that we have this, what we have before us is a stream of data, and we want to be able to read that. So I'm going to say while we're not at the end of this, we're going to go ahead and do something. Now, what we're going to end up doing is we're going to read this based off what's called a token. So I'm going to say qxml stream reader token type token. It's embarrassing when you can't spell token. Maybe I need more coffee. We're going to say stream.read next. So what this is going to do is it's going to keep reading forward and it's going to grab different tokens. What is a token? Let's F1. Yes. Enums, everybody's personal favorite. We have no token invalid, start document, end document. Ah, you see exactly what's going on here. It's actually parsing this document for us. Start document, end document, start element, end element, different characters, DTD, entry reference. I'm not going to go through all of these, but you can definitely feel free to read the documentation if you have a special need for these things. So it really just becomes a gigantic switch statement. And I'm going to plug in quite a bit of this just so we don't have to deal with it. That was a little tricky. I'm kind of impressed that I copy and pasted that because that wasn't all of it. We're going to actually type some of this out. So I'm basically just doing a giant switch on that token to see, hey, if you need a comment, this, that. But notice how we're coming down to start element. This is where we actually start caring about things. Let's go ahead and say, hey, if the stream name to string equals test, and I may have to update that uppercase. Let's go ahead and say qstring name equals the stream attributes So you can see exactly what we're doing here. So if the start element toString is test, then we're going to go ahead and get the attributes name. Now let's switch up to our write code super quick here. Notice how we have a start element test. I had to double check that because yes, I've had case sensitivity bite me before. I want to make sure. Now somebody out there is going to go, well, case sensitivity doesn't matter in XML. I understand that. I'm telling you, I've had it bite me before. So just be very, very careful on how you're doing that. Now, case sensitivity matters in C++ land, but not necessarily in the document itself. Whew. All right. And that is also mired in complexity. You'll see probably some comments about how, yes, it does, and no, it doesn't. Again, you're going to have to look at your special use case and what you need. Now that we've got that, what have we really done? Well, we've got an instance of our class, and you notice how in our end document, we're going to go ahead and set that map. So we haven't actually built that yet. Let's go ahead and build that out. And it's very, very similar. So I'm just going to grab this actually. And we're going to say, if that stream name toString is item, because that's our map, then we're going to build out those key value pairs. So it becomes pretty straightforward from here once you've wrapped your head around all that complexity. QString key equals, and we want the stream dot attributes. This is why when I work with XML, I tend to put things in an attribute rather than making an element and an element and an element. You'll see people do that, and it'll drive you absolutely bonkers trying to parse it all out. So I'll typically make an element and shove all the attributes I need in there. If I need sub-attributes, I'll do that, but I try to use them very sparsely, just because it can be a bit cumbersome to parse them out. And we want the attributes dot value. Now that we've got both of those, we can simply say map dot insert our key value pair. And we're going to build that map as we're reading it. And once it hits that end document, it'll set it for us in our class. We have one minor thing left here, and it was just one more little case. I probably could have put it before. Apologies. If we have an end element, then we may want to trigger some sort of action on that. Don't nilly for this little example here. All right, notice this potential memory leak of pointer. So of course we do need to return that pointer. Once we've gotten to this point, let's go ahead and give it a build, make sure I didn't goof anything up. This is always the scary part, watching that build. Hey, got a good build. Anybody who's done development knows that a good build doesn't necessarily mean the program's going to work. This is a lot of complexity. I'm sure I screwed something up. So let's go ahead and do this. We're going to copy these things because our converter uses the same API. Of course, we can just copy those. Again, there's probably a better way. You could just say like convert to, convert from, and then have an enumerated type. So we're going to write XML and read XML. And instead of write JSON, we're going to write XML. Instead of reading JSON, we're going to read XML. And then the API is pretty much straightforward. So let's go ahead and write XML path and read XML from our path. Moment of truth. Let's go ahead and build this. And let's run it. And device not open. What do you mean device not open? All right. It's on QIO device read. So we probably got, yep, there's our document out there. So it did write the XML file, but now we're having a hard time reading it back. Let's figure out why. Looking at this, it says read device not open, and then we got a blank name. So it's actually trying to chug through that code here. Device not open means we're trying to read it after we've already closed that device. Let's go into our converter. We're in read XML, We're closing it here, but now we're trying to, I see the problem. Right here, QXML stream reader stream file. We could have actually just handed it a file, but instead I read it all into bytes. So let's put data here. In case you're wondering what was going on, is I was handing this a Q file and it was attempting to work with the file off the stream directly. Instead, I wanted to read it all into one Q byte array, and that's what's going on there. So now we're telling it you worked with the byte array that I've already read rather than trying to read from the file, which I already closed. Silly programmers make mistakes. Okay, let's save and run. This should work as expected now. Ta-da, there we go. All right, so we've loaded our name and we've loaded our keys. Looking at this, you can see that XML is, by comparison to JSON, a bit more complex. You have this start document, you have all these elements, you have these attributes and all these crazy things, but it is heavily used today. And as you've seen from me working with it, it's easy to make a stupid mistake. So if you're working with XML and you get a little frustrated, just understand what you're doing here. You want to use a stream and you want to let it do the work for you. And yes, silly mistakes do happen.